dam to powerhouse. So you had the dam, and by the side of it, you have the water going to the main project, main powerhouse. But just below that, you had a small powerhouse which will remain operational, not in winter, but in summers, it will give them energy for the local area, the Gurez Valley. And that's the figures of the dish. That's the quantity or the volume of water, 59 cumecs, that was diverted from Kishan Ganga to Jhelum. And this is the quantity of water which Pakistan lost in their this Neelam Jhelum project. So the project cost was 5,500 crores, and the energy yield was 1350 million units. And incidentally, with augmenting of the water or the discharge into the Jhelum, there were 2 downstream projects which got benefit of this additional water. And as a consequence, their generation also improved. So eventually, 1350 from the main Kishan Ganga project, and I think 363 million units came from the project downstream. 2 hydropower projects, both belonging to NHPC. So this is the typical bar chart what we had done at that time, the various key activities. I don't think we need to go there. This is the inauguration in May, I think 18th of May. The Prime Minister, Honorable Prime Minister, inaugurated it in presence of Mr. Gadkari, Mr. R.K. Singh, Farooq Abdullah, all the dignitaries. Now a little bit on the construction methodology. You can see this is the terrain. This is the power station on the lower side, and on the right top is the dam site. So you had to actually traverse not directly, but through the sides, because that also I'll explain why we didn't go directly to the 2 places, but went slightly towards the upper reaches. Now this is the alignment of the tunnel. Like I said, there are 3 elements to the project. One is the dam site and the enabling works there. Then you have the water conductor system, and then you have the power generating side. So this is just to give you a context of this is the terrain you can see, very rugged terrain. And we had to get this because we needed some kind of an access, what we call Kanzal 1, Edit 1, to this edit. So rather than running it directly from there to the powerhouse, wouldn't have been possible. So in order to optimize the construction duration, we had to do a little longer tunnel, but that gave us better progress. So the line in blue is done by the traditional, what we call the NATM, New Australian this technology method, or drill and blast in plain terms. And the one in red is with the tunnel boring machine. And you have the dam complex at Gurez, the river, crossing over to Pak-occupied Kashmir, and then you have the powerhouse structures at the bottom. Now, this typically is, this is the Kishan Ganga. You can see the Kishan Ganga river flowing. So in order to construct this dam, and that's what I thought it would be important to share with you how it's done, we actually make a coffer dam. The upstream coffer dam. So what we try to do here is we will try to first make this connection. This is the diversion tunnel. So what we try to do is we try to dig a tunnel in parallel to the river and subsequently start filling up the river in the upstream coffer dam. So as a result of that, the water level increases and it gets diverted into the lower portion. And once that diversion happens and the coffer dam is completed, we do the downstream coffer dam just as a precautionary measure that the water doesn't backflow. And that opens up the space between the 2 coffer dams for excavation of the dam. And then you are free to do your own dam work without any risk of water seepage. We do obviously do treatment, the ground treatment for water, but that actually lets you a free hand. And then we have this intake tunnel. Now, in order to gain access to the water tunnel, we have to come from the downstream side, and then we start excavating upstream and downstream. And that's how the construction of the upper area is done. And we then flowed you can see it's here. It starts once you are excavated the tunnel, then you go upstream and downstream. And this is the tower which controls the flow of the water into the headrace tunnel. So those are some of the statistics of the upper area, or the dam site, as we call it. Now this is again the same representation what you saw in the earlier slide. You have the drill and blast method tunnel, the TBM tunnel, and some of the structures. Now the interesting thing here is that on the bottom, you can see this. This is the access road. Now you can see how difficult, literally it's 70 kilometers, going up the hill, past the Razdan top, and then go down into the valley again. So you have to meander across all these mountains to get to the dam site. And this used to be blocked. The dam site used to be cut off from the main valley up 4 to 6 months in a year. Now this is the middle portion, just upstream of the powerhouse, where the water comes through from the tunnel, goes along the slope. This is steel-lined pipes, and then into the powerhouse. And this is a inclined tunnel sort of, we call it pressure shaft, for which you need some accesses to gain entry into. And this is the powerhouse complex. So you can see the pressure shaft on the top, and then you have the powerhouse, the transformer cavern, and some ventilation tunnels, and finally the tail race tunnel, which takes the water out from the powerhouse into the river downstream. So some of the unique features of this, which sort of differentiate it from the other hydropower schemes, is that no intermediate accesses, adits we call them, were available for this. So literally from the more than 20 kilometers, we didn't have any access, and we had to go straight into the mountain. And accesses generally help in expediting the progress. And when we had these two tunnels. We had the TBM coming from one side and the drill and blast happening from the other side. When they met finally, there was an 8-inch, 20-centimeter difference between the two faces. So it was a fairly accurate tunneling that was done there. I talked about the 2.4 megawatt dam-to powerhouse. And as I said earlier on, no geotechnical information was available for this, because you were literally, the tunnel was 1,400 meters below the surface. Normally what we do is we do a deep bore and try to pick samples. But then we realized that even if there's a 1% inaccuracy, you would be about 15 to 30 meters away from the tunnel. So it's no point in getting that. Everything was done by actually physically moving on the surface and using your geological knowledge, engineering geology knowledge, to understand what would be happening 1,400 meters below. And as you would understand, it's very, very difficult to do that. And this was the first TBM which was declared as most successful TBM in the Himalayas. I worked on a project before this in 1990, where we had to bury the TBM because it just failed. But here, except for a 5-week stoppage, the TBM worked very smoothly, and it actually set a record in Himalayas of 817 meters of drilling and concrete lining. So it actually was drilling, and then also at the same time lining it, concrete lining it at the back with precast segments. So that was the kind of progress achieved. But overall, on an average, we achieved about 500 meters per month. And I did mention about the augmentation, because this was a intra-basin kind of a project which actually helped augment some of the power generation in the downstream projects. So I think we discussed this slide. So these are some of the faces. The one on the left side is, you can see that's the coffer dam. Now you started doing the dam excavation. That is start of the tunnel portal, as we call it, where you put in some steel ribs for the tunnel to go through. This is a representation of what the dam would eventually look like. This is before the construction started. And that's again a picture of the tunnel face. So for the designer, it was a British company. They were very apprehensive about the kind of risks that we would face on this project. And one of the risks which we found, which we knew, was that the river was governed by the Indus Water Treaty. This treaty is between India and Pakistan and divides actually the 6 rivers of the Indus Basin. 3 are, Pakistan has exclusive rights and 3 India has exclusive rights. Now this Kishan Ganga River forms part of the Jhelum Basin. So it was governed by that, and Pakistan did not want it to come up, obviously for the Neelam Jhelum, and also they were apprehending that there will be a huge dam. Initially, the dam had been planned to be about 90 meters, but because of the R&R issues, we finally had it at 37 meters. And one of the concerns which the designer had was about the security of the expat staff, particularly local as well as expat staff on the project. And the designer's risk was that there was no investigation available on the headrace tunnel. We were apprehending, and we did encounter it at a few places, squeezing ground conditions. When you have a cover of 1,400 meters, the rock also starts to crumble inside. When you do an opening, the wall starts sort of caving in. And if the TBM gets stuck in that, it's extremely difficult. You will have to eventually abandon the TBM. So those risks were there. Unforeseen ground conditions, which are typical of any, even after, like I said earlier, any investigations, extensive investigations, you still encounter unforeseen ground conditions. That was another risk because the designer had to provide for the designs. And the left bank of the dam had a lot of geological problems, very shattered rock that had to be strengthened and stabilized. And it also meant the reworking of the designs. I'll not get into the contractual and commercial risks because they are not really relevant to this discussion. So international issues, Indus Water Treaty, I mentioned about Kishan Ganga, Jhelum, Western River, safety concerns. Now this is very close, as you saw in that slide, very close to the border. Construction under the border shelling. And when we went in 2007 for early investigation or early assessment of the site, there was actually a Bofors gun on the dam site axis. So it's that close to the border. And this is the Indus Water Treaty. It was signed in September 1960. World Bank were the guarantors for the treaty. So when you look at it, so that was the international aspect. Now we have the security situation in Kashmir. We have had disturbances since late 80s, effectively, but it had subsided, but then we have had a few spells, 2008, 10, 12, and 16. But the most important one which we suffered was 2010, when we were actually about to transport the TBM, which I'll show probably a couple of pictures, a huge machine, and everybody got apprehensive that if it starts moving on the streets, how the people would react, what would be the reaction, what are they getting into it. So we had to hold it in Jammu for several months. And this project is actually spread over a very long area, large project area. Generally, hydropower projects at the best can be 10, 12 kilometers, 15 kilometers. But like this is 23 kilometers of strait, but you actually had to go and coordinate between 2 wings of the project, which were 70 kilometers by the road, and through very hostile, very hilly terrain, and also a pass. And those days, now it's been relaxed. For everybody, even the locals, you needed a permit to go to Gurez, because it was like those inner line permits you have in the northeast. You could not go in, there were army checkposts, and you had to get clearances from the administration. And I mentioned about this delay of the tunnel boring machine because of the, some disturbances in 2010, which delayed the transport of TBM and eventually the start of the TBM. And the advisories from the home countries were not. We had some expat staff from UK and a lot more from CELI from Italy, who had some travel advisories also. So you had to sort of negotiate, give them confidence, and get the necessary security apparatus into place, provide protections, secure your work areas, secure your residential areas, so that they would be allowed to work here. You can see the gentleman on the right in snow with his AK-47. This is a couple of pictures of the same. This is me. We had a team of, the owner of CELI actually was very interested in coming to this project. He also came with The ex-head of International Tunneling Association, Martin Knights, who was Halcro's tunneling director, and some more Atlas Copco guys, which is a very big name in earth moving and construction equipment. There, some of their senior directors also visited the site. And you can see the policemen surrounding. This was all secured first before they were allowed to come out of the cars. So on the geographical and logistical challenges, we had 300 kilometers to Jammu, the nearest railhead. And then from once you get into Bandipur, where the powerhouse was, we had another 70 kilometers, as I said, to Gurez. Transporting of heavy equipment had to be done through special trailers. And on the way, because there wasn't really any big project on the way from Srinagar onwards, we had done Uri, but the equipment here was different and the route was different. So we had actually to strengthen the bridges along the culverts, the bridges, the road widths had to be done. And particular problem we had, I'll show you a picture of the cutter head of the TBM, which comes in one piece. That had to be transported. It was a logistical nightmare to transport that. Razdan Pass, I did mention to you. And for access to Gurez in winter, so you had a huge inventory. You couldn't, I mean, if you lost a nut or a bolt, you couldn't stop work. So you had to create a large inventory so as to be able to supply the work phase. Plant, machinery, supplies, spares, and manpower. Where HCC tried to do a lot during the times with their own equipment, trying to keep it. Whenever there would be a snowfall, they will try to move immediately, mobilize the resources to move quickly and clean up the mess. And we also had a helicopter during the winter months, which was actually for evacuation of medical emergencies, staff transfers, even used by locals for medical evacuation, and also for some even sort of supplies, for consumables, vegetables, had to be transported to Gurez through the helicopter. It used to be there for the full winter, 4 months. And this is again a same representation. The yellow line shows the road where it's coming through. You can see it's a very lot of zigzag roads. This is definitely there. I'm not very sure of that. That's probably Sonmarg. That's Sonmarg Road. So, but it's something similar that was happening there. The right top image, it's basically from this Zojila tunnel. But this is the kind of terrain you have been operating in. And this is the cutter head. And this is again, not our cutter head, but a representative image of how big it is and how it's transported. So Gurez used to be cut off, as I said, for 4 to 6 months. You would get several feet, 8 feet, 10 feet. Many a times in winter, you would actually come out through the first floor. The ground floor will be all sealed. And minus 20 temperature. And you could not do any surface work during that period. And then you had these avalanches and cloudbursts happening. On the local issues, as in any infrastructure project, we had our set of land acquisition issues. Even after taking compensations, families were split, then they had to be accommodated, and more cases came up. There was a lot of focus on employing local manpower. In fact, we were discussing it. The skill sets were not available. So you had to struggle between that. You didn't find skilled or semi-skilled people there. Staff, because of this remoteness and the climate, there was low productivity, sickness, stress levels, low motivation. So you had to address those issues as well. Obviously, the environment lobby was very strong. They had their own concerns. They had been pivotal in getting this dam reduced from a 90-meter dam to a 37-meter dam. And international worker facilities, the cultural, the camp, catering, and the punctuality. They were operating in a completely different environment, and Kashmir relatively is slightly even different than the rest of the country. We are a lot more relaxed people, so punctuality was a different thing for them. So those cultural differences had to be addressed. So operationally, we had to foresee and envisage what kind of spares we would be requiring, and what other challenges we would face. Large inventory. Lead time was very long, to get material. And the equipment used to be very brittle. If the operator wasn't very careful in handling the equipment, he could actually break it, because at that negative temperature, the steel would become very, very brittle. And a lot of storages had to be done inside the tunnels, including, not very deep inside the tunnel, but diesel and all, because to prevent it from freezing, because it was a lot warmer inside the tunnel than outside. And actually, when we were doing, because we tried to keep the tunnel going in winter as well, so you would go inside and do a drill and blast, muck it, and don't take it out, because it will be all covered with snow. So stock it somewhere, and eventually, move it outside. So you had double handling of the muck that used to come out of the rock, the debris that would come out of the blasting. And then finally, the construction challenges which all projects in the Himalayas have is the geology and the tunneling. Himalayas are young mountains, very complex geology, and we are in a seismically very active area, zone 4-5, zone 4 actually, very high seismic activity. We had this earthquake in October 2005, which was not really far, probably 70 kilometers from our dam site. And limited investigations, so that was, and you would normally make some kind of assessment, but we literally didn't have anything to start with. There were sort of fragile geology, shared rock zones, rock masses, rock falls, and water ingress was happening. TBM design was probably the most successful part of this project, that it was custom made. The HCC allowed the SAILI to design the machine the way they would take the ownership and responsibility for it. It was designed for various types of rock mass and constant monitoring. It actually, whenever you move that machine, you would actually monitor and check what was happening inside and whether we were in for any surprises. And it was a very successful TBM tunneling. Squeezing ground conditions, I mentioned, at 1,400 meters. We did encounter it, but not as much as we had anticipated. Hot spring, hot rock bursts happening, the walls of the tunnel collapsing, mud inflows happening, those also occurred. And to prevent that, we would actually try to consolidate it by putting in grout and foam and other things to make the rock mass homogeneous. And we were also ready, if need be, we might have to go for some kind of a bypass or an exploratory tunnel to assess the, what was on the tunnel face. And this is just a picture of the, you can see the cover, the horizontal line is the tunnel, and then you have the mountains as it is. And the different colors signify different rock masses. And this is the machine that I'm talking of, the TBM. This is its sort of, when it was being put together. These are the hydraulics of the machine. This is inside the tunnel. You can see HCC SAILI's logo there. And then this machine actually, it operates, it turns around. I should probably go back. Sorry. So these small things that you see on the sides, they all rotate like this in a circular fashion, and the whole head rotates. As a result of it, it squeezes or grinds the rock, which is collected at the base and then moved on a sort of platform, and then transported through a rail, a wagon, and then dumped outside. So that makes the operation very, very smooth. So this is that setup, the backup. This is the one which takes the muck so that you don't have to stop. It keeps boring, and then you have these precast segments, these ones. This is the kind of a tunnel face you had. So you put them together at the back, and as you progress tunneling on the back, you are putting the precast segments and taking the muck out very smoothly. And I thought it's end of autumn in Kashmir. So this is Gulmarg. You might have heard about the name. 2 pictures taken from the same location. We are waiting for the area to be draped in snow. Anytime, maybe week, 10 days, it should be like this. It will move from that rust brown to white landscape. Thank you very much.
Thank you, sir. Your talk brings clarity to the challenges and choices that define hydroelectric projects of this scale and relief. That was truly insightful for all of us to understand the decisions and groundwork behind such impactful projects. Our next speaker is Mr. Love Anandjiwala, Director of Anandjiwala Infra Advisory, presenting the Zojila Tunnel project. This tunnel provides all-year access between Jammu Kashmir and Ladakh, making it an essential piece of infrastructure in the region. Mr. Anandjiwala, I welcome you to take the stage.
Good afternoon, all. Earlier speaker has covered most of the challenges working in Himalaya, including the geological and other risks. I'll focus on certain other aspects of the connectivity in Kashmir region in this presentation. The Zojila Tunnel is currently developed by NHIDCL, which is under Ministry of Road Transport. The project has two components. One is connecting road between Zedmore Tunnel, which is known as Sonmarg Tunnel, and Zojila Tunnel. That's about 18 kilometers of road, and another is 14 kilometers of main tunnel of Zojila Tunnel. It's a EPC contractor where client is NHIDCL. We are the authority engineer, and the contractor is Mega Engineering, Hyderabad-based company. These are the few projects we as a consultant carried out DPR. The serial number 2 project is where we are working as a supervision consultant as well. This project we have designed as a consortium, as a designer, DPR was prepared, and now we are doing supervision of this project. These are the two ongoing projects. This Zedmore Tunnel has been completed, inaugurated in January, where we were the independent engineer, as this was the DBO40 mode, and the Zojila Tunnel we are working. Part 1 access road has been completed, which is not under operational as of now. Part 2 is under construction. Earlier it was 18 kilometer, but after designing under EPC, the approach road becomes 17.7 kilometer, and 14 kilometer tunnel become 13.15 kilometer. Once constructed, this shall be world's longest tunnel at 3,000 plus meter altitude with total length of 13 kilometer. Now I'll focus something on the connectivity in Kashmir region. If you see, this is the Jammu region. Jammu to Srinagar, you have connectivity of NH44, which was earlier known as NH1. Now we are looking at two more connectivity from Jammu via Doda, Kishta with one is NH244. Another road under construction is from Jammu, Akhnur, Rajouri sector to Srinagar, that is NH144A. Now you have Sinthan Pass and other two high mountainous passes near this area. So accessibility to Jammu, all-weather connectivity, if we talk about, is NH44 as of now, and 244 become another connectivity. Now it is important to understand this connectivity because Leh is connected via Srinagar, this axis, or from Himachal Pradesh from Manali onwards. Now Leh is cut off for 6 months because from Himachal, if you travel, there are two high mountainous passes. One is Lachungla, another is Tanglungla, which are 5,000 meter plus altitude, so which are closed for 6 to 7 months a year. Earlier, this Srinagar road, you have one is Zedmore Tunnel, and the Sonmarg village was cut off. That is where these tunnels were envisaged on connecting NH1 from Srinagar to Leh. Now the conceptualization of Zedmore was initially started during the Kargil war, where Kashmir, the Pakistan occupied the peaks of Kargil, and that created a problem to Leh. As Leh was basically cut off for 6 months, all supplies to Leh was done for 6 months from Srinagar axis or from Manali side. Fuel storage, everything for locals were supplied in 6 months. After this Kargil war issue, it was decided to construct all-weather connectivity between Srinagar to Leh and from Manali to Leh. These two are the priority of government to connect Leh. Once completed, Zojila project will stand as monumental achievement in India's infrastructure journey, showcasing engineering brilliance and strategic foresight and human resilience. As we speak, our project team is taking those with innovation, agility, and technical prowesses. We have done about 12 kilometers of drilling out of 13.1 kilometers. I'll get into that part. Now, while I was discussing about Srinagar to Leh connectivity, if you start from Srinagar, from Gandarbal, Kangan, you reach a place, Gagangir. So if you see, this is a Z-shaped place where valley is very narrow, and you don't have sunlight available for snow to melt. So because of that, this particular road get snow-filled. For about 6 months, you don't have connectivity to Sonamarg village. So due to this, to connecting Sonamarg, this Zedmore tunnel was envisaged and constructed, which was inaugurated in January by Prime Minister on 13th January. So we were the independent engineer for this project. Once you reach Zedmore, and the Zojila tunnel was under construction, so this 18 kilometer, if you don't have all-weather connectivity for this 18 kilometer, there is no use of those two tunnels because you can't have connectivity up to Leh for 12 months. So that is where this particular road was designed for all-weather connectivity. Now, this is the this particular is the Zedmore. This is the main road, and this portion dotted line is the tunnel which connects to Sonamarg. If I come to the layout of Zojila, so if you see here, this is the exit of Zedmore tunnel, which is now known as Sonamarg tunnel. This is the approach road, and from approach road you reach to the main tunnel, which is at Baltal. Now, if you see, there are multiple structures of this particular 18-kilometer road because to make that all-weather connectivity. If you see there are two tunnels on this, then there are cut and cover sections, snow gallery, major bridges, minor bridges on this side, right-hand side of this slide. This particular road has been constructed. Now, this is a particular image you see. This is provided by SASE, which is under DRDO, which does research. SASE and Wadia Institute are one of the few Indian institutes which does primary research in this region. So these are the fans under which landslide and avalanche come. This is where this approach road, to make it all-weather, you have to build multiple structures, which I'm going to explain furthermore. These are few statistics of project, which project started in October 20. Likely completion now is 20th October 2028, as informed by government in Parliament. Presently, we have managed to guide EPC contractor about 12 kilometers tunnel excavation, and breakthrough of this in heading is expected in April 26. These are the few structures lengthwise, which I'll show in further video. Earlier, I showed you the layout of part 1. Now, this is the part 2 where the entry point on west side is 2900 meter elevation, and the exit at east portal is 3300 meter. So 400 meter gradient in 13 kilometers. Then there are 3 vertical shafts to be constructed. These vertical shafts were provided with 2 reasons. One was for ventilation, and another was for getting more adits for construction purpose. The shaft is of 200 meter to 470 meters. These are the proposed depth of shaft. Now, these are the cross sections. I'll not get into these particular cross sections. Now, I'll just show you the current progress of Q1 2025 tunnel. Sorry. Let me start with. Yeah. So this is the start point from chain at 0 if you start. I guess this was in February. So if you see, there are structures along the road. These are the few structures. You'll get further video. The importance of this structure will be known in further video. That's a bridge 3 we are talking about. This is the first tunnel, which is about 490 meter. This is going into tunnel, another tunnel. So this is a labor colony area. This is a cut and cover section. If you see, this is the labor colony on right hand side. This is the main road, and further is the cut and cover section. These are all the cut and cover sections for avoiding snow slide avalanches. So this is particular structure where we are talking about the snow gallery. So this gives you, the left-hand side is the hillside and right-hand side is the valley side. So during the snow time, through these openings, you can see the snow outside. So this is a snow gallery for viewing purpose has been provided as a structure. So that's a portal side where, if you see above is the temporary ventilation system. This is a raised borer. If you see, this is another equipment which is generally used in the mining, gold mining or coal mining. This is a very important structure because working for shaft from top down becomes very challenging because you are working against gravity, you are mucking something and getting out. So to fasten the process, once you reach a particular level, you can start from bottom up construction. About a 2-meter dia borehole basically is getting constructed. These are some of the construction sequences. Now this is a shaft location at top, Zozila top we are talking about. This is a shaft 2. Getting into east portal where tunnel lining has been started. So if you see, the material has been stored inside the tunnel for faster construction as well as from having a backup supply. I'll just get into. So this is a typical tunnel construction sequence we are talking about. I'll show this through pictures. First the survey is done, tunnel alignment has been marked, then the face drilling starts where you put gelatin charges, and once a blast is taken, there is a fume. So that fume gets defumed through temporary ventilation systems. Then you remove the muck, and then you start putting up the primary support system. After doing mucking, you put shotcrete, then you put loose, so that loose rock fragment doesn't detach. Then you put rock bolting and pipe roofing, other systems you can put it. These are the few terminology. This is the heading. So first the heading has been constructed, then you do benching. So you start 2 things parallelly, you can do it. Once you reach a certain level, then you can start heading benching together. This is the shaft construction through raised borer, where a person is, if you can see the person is standing over here, this equipment goes up and you can drill it and you can put the gelatin charge into the rock area. This is a PVC membrane and reinforcement done. This is a gantry through which concreting is done for the lining purpose. So this is basically ventilation slab. So once tunnel is constructed for ventilation system, there is a slab constructed, and then you can put the ventilation system over here. Now, this is the current status of tunnel. If you see, there are 3 vertical shafts. In heading, tunnel has been completed about 12 kilometers, 6,000 meters from western portal, 5,900 meters from eastern portal has been constructed in heading. In benching, 4,200 meter from west portal, 4,000 meter from the east portal. So about 8-kilometer tunnel in all respect has been constructed. Lining has been started parallelly. If you see lining, from western portal, you have about 280 meter lining done, and on eastern portal, you have about 2,000 meter lining done. So that's a lining, complete tunnel has been constructed in this manner. These are few types of rock currently available. So heading is done, although it's on 27th November, but this number is old. We have got more than 12,000 meter in heading. In benching, it's 8,300 meter plus progress. Now, these are the challenges which earlier speaker has already discussed about the desktop study. There is not much study available for the for the tunnel construction in Himalayan region because the accessibility is a challenge. Few of the working tunnel in region is Chenani tunnel, Atal Tunnel, Kiratpur, Nerchok, Zedmore, and Kazikund Tunnel. Except for Kiratpur and Atal Tunnel, every other tunnel is in Kashmir Valley region or connecting Kashmir Valley. Currently, the Shinkula Tunnel is under construction. It's done by BRO, and the portal is at about 4,000 meters. That might be the highest altitude portal as on date in India. The geological mapping was again another challenge on this project, like every other infrastructure project in this region. Accessibility to site was available for 6 months due to the snow, and on hillside mountain you have snow for more than 9 months. So you can't access hillside part. So you get 3 months to do investigation on hillside, and otherwise within this limited period, whatever geological mapping or hazards you can measure, you can do it to incorporate in the design part. After geological mapping, if you're looking at geotechnical investigation, as alignment pass through various hill portion, you don't have access to most of the tunnel portals. So wherever you get space, you try to do geotechnical investigations. On this project, there were only 10 boreholes drilled, maximum depth was 480 meter. An EPC contracted, and 2 of the boreholes were at shaft location, so you got majority of the idea. 480 meter was at the first shaft on the western side. So apart from that, not much of the investigation was done during the DPR stage as well as during the EPC contract stage. So most of the design factors were done on geological mapping. And as we go in NATM, on the face mapping, the design was done, the support system. So there are 7 types of section in this particular based on the geological mapping, that this tunnel of 13 kilometers distributed in 7 sections. Now, coming to engineering challenge, as once complete, this will be the longest at 3,000 meter altitude. Now, another point of discussion for the construction methodology is whether to adopt NATM or TBM. As earlier spoken about, what is best. Now, Himalaya, because of limited investigation, we are not very much clear what kind of challenges geological will encounter. So generally, on a safer side, people look for TBM, NATM, not the TBM. On this project, because there were only 2 phases of working on western portal and eastern portal, there were a deliberation that whether to go with TBM or not, because TBM might give you a faster construction. But looking at the site conditions, for your TBM, you need lot of space for concrete precasting and a flat ground, which was not available nearby area. So it was decided to go through NATM. Now, heavy snowfall is again another challenge, is where you have to design your concrete and bitumen for this kind of temperature. Minus 45 degree is a reported temperature in peak winters in eastern portal side nearby Dras. Road construction and in low bitumen area is again another challenge, which is because road construction is carried out basically between 10 degree to 12 degree temperature, which you get probably 2 months time. And while constructing also, you might get rain or snow, so that particular patch of road, you have to redo it. Now, maintaining quality and temperature of routine concrete is also become very difficult, because you have to use accelerator, you have to use hot water to do the basically concrete preparation. Temporary ventilation system is also required, because further you go into the tunnel, you'll have more muck coming out of, more fume coming out of it, so you need a strong ventilation system. This main tunnel was having 2 phases, west portal and east portal, so time cycle was increasing. As on date, if you are at 6 meters from both the sides, taking out muck of 6 kilometers becomes very difficult. It requires a lot of resources, and now the per month average has been reduced because you are taking more time to taking out the excavated material. Currently, the construction of 3 shafts is going on. Efficiency of construction equipment is also, you need to put all new equipments. Old equipment will not give you the kind of output you are looking at, and the maintenance of those equipment becomes also critical. Another aspect is, because this is a road tunnel, the ventilation system is also critical, plays a critical part. Most of the Indian tunnels has different types of, on this particular project, a different type of ventilation system has been proposed due to extreme temperature variation and the air pressure. Now, I'll not get into much about this ventilation system. This is little too technical part, but the EPC contractor has proposed semi-transverse ventilation system. Probably first time in India this has been proposed. Now, these are some comparison of fully transverse and semi-transverse. Most of the Himalayan tunnel currently has a fully transverse ventilation system, but for this particular project, semi-transverse has been proposed. Now the execution strategy. As this kind of mega structure has not been done in India, bringing experts with that kind of experience was on board was a challenge, considering the geopolitical issues and the climatic conditions. Most of the designers who have experience working in snow mount region are from either Austria or Italy or European region. Now, getting them on board with the foreign advisory, the other aspects was very difficult. So from a consulting side, we had expert coming from, an Irish expert coming on our project. But for him to understand Indian contractual provision, because Europeans are more familiar with FIDIC contracting conditions. For them to understand EPC contract become difficult. We have to teach them, you have to make them understand certain nuances of the contracts. Now design standards. At this altitude and this long tunnel has been not designed. So Europeans would have their own mindset to design tunnel, but that might not be part of IRC guideline. That might not be part of manual. So there were a lot of deliberations, discussions about design standards and type of contracts provision. Another challenge during execution was accommodation for staff. At -20 to -45 degree, how do you accommodate 1,000 plus laborers? As on that, there are 1,200 laborers working and engineering plus driver and other staff. So on Zojila tunnel, there are more than 1,500 people working, and everyone has got accommodation, which is heated accommodation with by and large 18 to 20 hours of power supply. There is a power supply coming from Jammu Kashmir Power Department, and in case of power cut, we are using the backup generators. Additional storage facility for fuel and construction material was also necessity for this project, as most of the material is coming from Jammu, Haryana, Punjab region, where it is coming from NH44, which gets cut off due to landslide and other issues. So additional storage was very much necessary. Water heating system is also necessity for concreting work. Rotation of staff also becomes necessity, because at that high altitude with lack of oxygen, decision-making ability gets questionable. You have blood pressure issues, normal people getting, breathlessness, lack of sleep. Those are the issues. So changing shift of people, putting people from east portal to west portal because of the altitude difference and temperature variation also is a necessity. New equipment, contractor brought all the new equipments to have a better productivity and less maintenance and less downtime. We need to deploy even snow clearance equipment also for the approach road, because you need more than 48 hours. If snow gets accumulated, it becomes harder. So to remove that snow becomes very challenging. So the moment snow stops, you have to deploy this equipment to clear the snow. Shaft construction is the most challenging, because from top side on Zojila top at 3,500 meter, you don't have accommodation facility available. So the top-down shaft construction gets only 3 months of time. So majority of the time it was bottom-up through shaft through the raised borer. It was done, and yeah. So dewatering against the working gravity was also a problem. These are few site photographs. This is the Zojila main tunnel waste portal photograph. This is east tunnel photograph. These are the ventilation shaft construction where demucking is happening. Excavator material is getting out, and it is removed through this equipment. So Nilgirar, what I was talking about, a 400 meter and 1900 meter tunnel. So it's a twin tube tunnel. So that's a gantry for final lining. This is a road construction. Few special material has been used to remove the freezing and thawing impact. This is a construction of cut and cover section. If you see, that's a hillside and valley side, you have material debris coming in. So through cut and cover section, the debris will flow over the cut and cover section to give you accessibility. This is snow clearance activity happening That's a photograph of East Portal from the residential accommodation of worker. This is during construction in 2023, where the bridge 3 was under construction during the snow time. This is the shaft location. This is the central shaft construction. Again, it's a January-February photograph, Q1 photograph. Few side photographs after construction, after installation of lighting for part 1. Now, this is the kind of challenge we're talking about. If you see, this is a structure, in concrete structure. That's a snow avalanche on site during construction. This video is of February 24. If you see, the design of this structure helps stop snow coming from the hill other side of the road. That's how the importance of these structures. It's about 3-kilometer chainage after Sonamarg village. This is the section of after Sonamarg village. So this is from the approach. This is of the approach road section. Then you'll see video of campsite. This is the batching plant area and campsite where the same structure, nearby location. Then the concrete batching plant, if you see, the mixture machine. So same day, from 3 or 4 different views, these videos have been taken and edited to show you the real challenges working during the peak winter season. Now this is a snow slide. If you see, the avalanche and snow slide. So during the sunny days, after snowing of 2 to 3 days, snow starts melting and you can have this kind of slides also on the road project. So drivers have to be very careful while moving to look at the hillside to see any movement. So that's a snow sliding. This is the snow clearance. After 2 or 3 days of snow, you start putting equipment so that accessibility to tunnel portal or the labor colony or site can be established through the snow clearance equipment. Removal of snow. So this is a quite less snow. You'll have 20 to 30 feet of snow in peak winters because you are clearing day in, day out. Otherwise, in normal scenario, when you are not clearing snow, it will be 20 to 30 to 40 feet of snow. But because within 2-3 days you are clearing, you have 7 to 8 feet of snow. So Himalayan brown bears visiting our project site in one. So that's a material storage on site, and this was the first spotting of brown bear, and after that, probably every week we were spotting that. So there were some advisories issued for the contractors, workers to travel in group, not to walk on this constructed road. These are some benefits of Zojila tunnel. Now this is a photograph of, I like to show photographs of Zedmore tunnel, which is before Zojila tunnel, which this portal connects the Sonamarg village. This was inaugurated in January. This is the west portal of Zedmore tunnel, which is known as now Sonamarg tunnel. This is the approach road for this tunnel. It starts from Gagangir village. This is the start. This on the left side image is the start point of Zedmore tunnel approach road. EPCO is the contractor, DBFOT contractor, concessioner. These are the few approach road and viaduct photographs. And this is the admin building and the control center on the right side images on the east portal of the tunnel. I guess that is it from my side. Yeah, thank you.
Thank you, sir. Your talk added a lot of context into one of India's key infrastructure efforts. Your insights offer valuable learnings to the complexities of tunnel design and development in such a region. We now open the floor for both the speakers to join us on the stage.
Okay, we can take questions one by one. Any hands?
Just one question. You both talked about EPC projects with limited ground information. So under these circumstances, for a contractor to bid, you would normally think that either they would gamble or they would bid very high. How does this work in practice?
I think it's just a matter of the risk perception and risk mitigation. Eventually, we all know contractor will not pay from his pocket. He will actually load it to the project. So in simple terms, as I understand it, they load it onto the project with a certain caveat, with a certain understanding, trying to do their best, engaging very good consultants who can add value to it and give them a better understanding of what the risks are and how best to mitigate it. And beyond that, they will load it to the price. So eventually it will add up. I mean, Kishanganga should not have been as expensive as it turned out to be, had it been a normal project with an extensive investigations. I hope that answers the question.
So just as a follow-up, I mean, when bidding happened on Kishanganga as a project or other projects, what was the variance in sort of, let's say if you had 3 bidders, what kind of variance did you kind of see in the bids that came in? I mean, what was how much tolerance does the industry have for projects of this kind?
In the case of, I don't vividly remember now, it's been about 18 years, but I don't think it was a big difference in the prices. But surprisingly, I mean, it's just the way the bid was put together, the other bidder had put most of the money on the dam and minimum on the tunnel. So if you look at from that, it was a good contract strategy because the dam had the least risk. And if the tunnel gets stuck, it gets stuck. But HCC had put more money on the tunnel part of it, the way they had calculated it. But there wasn't really a big difference. It was a very small difference, and I think probably 5-7%, not more than that.
For the Zojila project, probably it's about 500 crore difference between L1 and L2 bidder. So 4,500 crore and 5,050 or 5,080 crore. That was the difference.
That would be same 10% roughly.
Any questions from students? You can ask.
My question is to Mr. Lawan Anjiwala, sir. Sir, just in your presentation, you told that you use special materials to prevent freeze and throw conditions in the construction of road. Can you just give the highlight? What was the material and how the proportion you utilized during the concreting of the roads?
Road is a flexi pavement road, bituminous road. So in subgrade, some treatment was done. I don't have currently information available. My RE resident engineer would be having available. If you require, I can share those details with you.
Okay. Thank you.
Good afternoon, sir. My question is for both of you. You both have mentioned that geotechnical data is very limited because of the terrain condition. So while executing the things or the structures, how we can freeze the design of that particular structures?
So in NATM, basically you do face mapping, and every section before you take blasting, after blasting, you decide the support class. So every 2 meter of pull or every 1.5 or 3 meter of pull, you decide on the spot through geologists the support class. So as you drill, you decide the design support SAP. Overall, there are two types of lining: primary lining, which is designed on site, and secondary lining is to stop squeezing impact or water ingress into the main tunnel. So primary lining is on the site decided by and large, with limited geotechnical investigations.
Sir, one more question. While doing this tunneling, that mud comes out. So it is usable, or means where we used it?
Again, depends on what kind of muck you are getting. But for Zojila project, the most of the muck was utilized for the construction of embankments for the road. So it was utilized, then it was utilized to create a landfill area for the parking purpose. And that parking will in future utilize as a playground or other amenities for government, local Sonamarg Development Authority.
My question to Iftikhar sir. In Kishan Ganga project, the part of the tunnel is NATM and the part has been constructed through the TBM. Now, what is the logic to switch over the method, or it is only just time point of view, only it has been changed?
No, I think the TBM was done only to expedite the progress.
Okay, but
Like
which,
what he said about the tunneling, if they had also explored the options of TBM and the NATM. But it would take much longer to do NATM, and TBM would be much faster. It's more expensive, but it was just a logic because you didn't have any excess. The time for mucking, once you do a blast, you have fumes. Then you have to take out all those fumes. Like what he
Yes.
said, as you get deeper into the tunnel, the time from the face to the portal where you take the muck becomes longer. So that actually increases the cycle time. So that becomes a problem. In case of Kishan Ganga, we had this edit, if you see at the top. So we tried to optimize it as much we could from both sides. So it would go in, we would do one blast here, and afterwards go here. Then next one here, next one on the other side. But the TBM was just going straight through.
yes.
So it's just about optimizing on the time, because the cost of the project increases. The financing cost becomes very high if the project is of a longer duration. So you might want to put in more money, buy a TBM, do it even with an expat input, and eventually come out winner with the lower interest rates, financing costs.
So how much additional per meter cost if we just switch over from NATM to TBM?
I wouldn't be able to recollect, but it would be more than 2 to 3 times.
2 to 3 times. Okay.
So I had a question from both the speakers. So what were the major key learnings from the project? If we had to do it again, except the newer technologies, what would be the engineering decisions that would be changed, knowing all the risks?
I don't think really much. I mean, obviously, we would be geared up to do a better job. We might have had some failings in there. I mean, I'll typically, now that you mention it, I worked with Skanska, which is a Swedish company. So in HCC, we would have the spares, let's say the gearbox of an excavator. There was some problem with it. The Swedes would not wait for that. They would change the whole gearbox. So they had 3-4 they had whole assemblies done. So literally there was a time, but that's all when you do these projects, learn the problems and learn the issues, you could do better. But I don't think there will be a huge difference. It will be just smoother if you go forward.
From government perspective, the contract management, contract administration, if contracting terms are from government perspective, if they look at contract part, the terms and conditions, based on the learning from this project, the difficulties faced in payment scheduling, Schedule H and other aspects, probably that might be the factor for reducing further cost.
But I think we had an advantage in that respect because we had a race with Pakistan to finish the project earlier than Neelam Jalam, so we didn't really have that kind of a problem. We were asked to expedite it as much as we could.
There's There's one hand there. That's the last one that we'll take. I'm sorry.
Sir, I want to ask a question about human resources. मतलब skilled worker, unskilled worker, engineers. તમે મેનેજમેન્ટ કઈ રીતે કરતા હશો મતલબ ઓન સાઇટ ઉપર એ લોકોને મતલબ એ લોકો કઈ રીતે એગ્રી થાય સ્કિલ્ડ વર્કર્સને બધા કામ કરવા માટે એટલે આમાં મેન પાવર વધારે જોઈએ તો
So manpower resources requirement are limited. 1,500 people probably on such large projects are not much because most of the work is done through equipments. Now, people are coming from various geographical locations, but most of them are from Kashmir regions. Most of the engineers are from Kashmir region because we got resources from people working on Indian Railway between the Katra line, which is under construction, which got inaugurated recently. So we got more resources from that project as well as from hydropower projects. So post 2020, we didn't face much issues for engineering staff. As far as class 4 or the drivers and cleaners are concerned, we got local resources. But otherwise, contractor manage other laborers from their own resources, wherever they got people. So at the end of the day, cost of labor increases due to risk and other factors. Otherwise, you get resources in this extreme region as well.
One last.
Hello. Are there any change in the designs conceived initially because of the construction and engineering challenges or geological conditions?
For this Zojila tunnel?
No, for either in such kind of projects.
So it's an EPC contract. So client is, for the road tunnel, let's say point A and point B are given under EPC mode. So design is contractor's responsibility. But they do have done a value engineering proportion where they have shifted a western portal location by 300 meter further, and that has reduced the length of tunnel by 1 kilometer. So that's a value addition, value engineering contractor did on their own. So about a kilometer, so that's about 9 months of construction they have reduced by doing a value engineering.
We basically look at it unforeseeable and unforeseen. So unforeseeable is, it's beyond what we could have foreseen. But for foreseeable, like what he was mentioning about you do the mapping of the face, then you look at the different rock support systems that you require. So that we already have them ready-made designs that in case this comes through, then you can adapt it to that design. But if something, like I said, squeezing ground conditions. So we had already designed the TBM for a squeezing ground condition. So if that happens, you would be able to address that. You could enlarge the cutters to open up spaces. Or you could even do, if you suspect something, you do probe drilling. You do 30 meters of drilling and take samples and see what is likely to happen. So you are a little more sort of comfortable, or you have got a better understanding of what's in the immediate future, lying ahead of you, rather than a long 23-kilometer stretch.
Thank you. Now, on behalf of CEPT and CRDF, I would like to present these mementos to the esteemed speakers as a symbol of our appreciation and support. Thank you, everyone. We now break for tea and reconvene at 4:30 p.m.
thanks to my audience, because when I entered around 10:30, I could able to see the conference was full. So at least I could able to see 75% occupancy. It is very good. So thanks to the audience. You are deserved for the applause for me. And so now the 30 minutes has been given to me. So to the justice to the point, the time is given to me. I will run the slides. Where it is significant and salient, I will speak. Otherwise, I will move on. So my flow of presentation will be, first, what is the benefit of the high-speed rail, and what is the salient feature of our project, which is having the construction methodology, followed by casting. And hallmark of the project is full-span box girder, having 1,000 metric ton single element, concrete element. How we are getting casted and lifted, and then technical challenges and how we have overcome that, and technology support, how we implemented in this project, sustainability initiatives. Our company is focusing on digitalization, and end with future HSR. We are anticipating from which sector that will be coming. With this, I start, since this committee has told more or less the students having more strength. So I will be presenting a video which represents the construction methodology of how the bullet train has been constructed from the ground level to superstructure.
High-speed rail is emerging as the fastest form of rail transport, with a speed of more than 320 kilometers per hour, using an integrated system of specialized rolling stock and dedicated tracks. L&T Construction, India's largest construction company, is constructing the Mumbai-Ahmedabad high-speed rail corridor. C6 package, which starts at Chainage 401 near Vadodara railway station.
It is my package.
And ends at Chainage 489 near Ahmedabad for a length of about 88 kilometers. The HSR alignment consists of 87 kilometers of main line viaduct, 4 major river crossing bridges, Mahi, Mohar, Vatra and Meshwa, 1 station and maintenance depot at Anand, Nadiad, 4 sub-maintenance depots and 2 railway crossings. The elevated corridor is supported on pile foundations and hammerhead piers with a superstructure of full span box girders and segmental box girders carrying the track. Construction methodology. Board pile construction. After the setting out of pile coordinates, a temporary casing will be driven using a piling rig. A prefabricated reinforcement cage will be placed using a crane. Concreting will be done using tremie and crane. Subsequently, pile cap, pier and pier cap will be constructed. Bearings and seismic stoppers will be installed on the pier cap. Shinso pile. Shinso pile of 7-meter diameter will be constructed at Chainage 405.161 National Highway 8 crossing. It is constructed by excavating soil while supporting the bore wall with corrugated steel circular liner plates. A prefabricated reinforcement cage will be lowered and concreting will be done. Subsequently, pile cap, pier and pier cap will be constructed. Casting yard setup. In the C6 package, the casting yards are planned adjacent to the alignment for ease of access to the work front. The fully functional casting yard has casting area, stacking area, office, labor camp, rebar fabrication yard, and lab facilities, aggregate and cement stock areas, and other necessary facilities. River bridges, segmental construction at Mahi. A temporary approach bridge will be constructed to access the foundation locations. Well foundation. A temporary coffer dam is constructed using steel caisson to develop a dry working space around the pier locations. Construction of the well foundation consists of taking it down to the founding level through all kinds of substrata by sinking, plugging the bottom, filling inside the well, plugging the top, and constructing the well cap. Subsequently, the pier and pier cap will be constructed. Erection of precast box girder segments. Launching girders will be erected over the completed pier caps and over the trestles supported on the well cap. The launching girder will lift the segments by rear end feeding and position the segments in their respective order of place, and temporary stressing will be done to align the segments. After the completion of longitudinal stressing, the entire span will be lowered on the bearing over the pier cap. Built in coalition with Japanese technology, the high-speed railway network will be yet another world-class infrastructure facility in India.
Yeah, what is the benefits of this high-speed rail in India? The first is obviously the economy will be getting boosted. So economy is directly linked with your time and the distance when it is getting reduced. Then it leads to the productivity increase, business increase, then automatically country's economy will also go up. So one of the best mode of transport what we are seeing across the world is high-speed rail, which is directly having the boosting of economy. And the second is employment, direct and indirect. In other ways, the employment is getting increases. Then mobility, for example, if somebody wants to go to Mumbai, so normally Mumbai, if you take Vande Bharat, it takes 6.5 hours. And if time permits and your work is getting over, then you can catch 4 o'clock and you will be at Ahmedabad maybe by 9:30 time. But in the high-speed rail, it takes only 2 hours, 70 minutes non-stop. Limited stop takes 2 hours, 30 minutes. You can leave by 6 o'clock, there by 9:30. 10 to 5, you can complete it, and you come back. So that is the benefit which I have experienced in the people who are traveling from Tokyo to Osaka, which is 700 kilometers, traveling with 2 hours. And one more longest travel is 1,300, Beijing to Shanghai. It takes only 4.5 hours. So morning 6 o'clock, you will be there at Shanghai 10:30, and vice versa. So that is the one benefit is there in high-speed rail. Then, yeah, real estates, last one video I will be showing how Chinese are constructing the satellite towns, smart cities first, then they are connecting it to the bullet train. So instead of being in the city, you are away from the city, but you will be connected with the city. That is the real estate booming. And yes, obviously industry is getting boomed up, but now our Honorable Prime Minister is telling the Make in India initiative. It is really helping. For this project also, I will show the next videos where L&T is also manufactured through that indigenous method of behemoth equipments. And then the last one, it attracts the tourism. So just I explained that train takes 2 hours, 7 minutes, I mean bullet train. Then if you go by air, that takes 1 hour plus check-in time, 2 hours. Then your airport always will be not at the center, will be at the corner. So from the corner to center of the heart of the city, it takes minimum 30 minutes to 1 hour. But the bullet train goes at the BKC, heart of that city. From there, wherever you can go. So there will be a comfortable. What I have seen in bullet trains, if the 4 officers or managers are sitting there, they rotate the seat to 180 degree and then face each other. Then they will travel as well as they will be discussing about the meeting, what they want to do it. That I have seen, but I can't able to understand Chinese language, but I could witness that. Okay, so but that is good. And the next is Vande Bharat. Everybody knows around 6 hours to 6 hours 30 minutes. The normal car, if you want to take it, it is around 8 hours after taking 2-3 stops for refreshment and bio break. And the bus takes 12 hours. So high-speed rail is evident that it is the shortest time it takes in the travel. And yes, I can't compare with, I mean, Chinese already crossed this 38, now they have crossed the 40,000 kilometers. High-speed rail corridor has been made already. The next country is Spain, followed by France, Germany, and one more country. That 4 countries are falling in Europe. But after that, few Asian countries, Middle East countries, and Indonesia started, but the kilometer-wise, it is very less. But India, if you complete this 501, India will be at the 12th position. And other 4 countries, their area is fixed. The high-speed corridor is fixed. They can't expand it. But there is an opportunity for India, since we have been widespread across 3,500 kilometers east to west and 4,500 kilometers north to south, we can able to touch, we cannot touch that 35,000, 40,000 kilometers, but at least 10,000, 12,000 kilometers we can touch by 2030, 35, maybe 2050 also. So yes, Honorable Prime Minister, when he visited last week, he was telling about we should get around 3,000 kilometers from few corridors north and south. So if you touch that 3,000, then we will be that 3rd position after Spain. And why this particular Shinkansen has been selected for this Japan, first thing I tell openly, we have to get the project financing. So Japan Overseas Fund, that is JICA, if you're going for that, then if you use their technology, the fund sanction will be better. That is the first thing. The second thing is, as on today, it started in 1964. Till now, the 0 accident. The degree of safety is 10%. I've compared with a few countries, Spain. Just Spain 3 years back, it was derailed. And France, China also. So there is a good safety record. And then the efficiency of the power consumption is very less in Shinkansen. Then carrying capacity is approximately around 750 to 800 people can travel in one train. Then the record of the time of arrival or time of departure will be minus 1 minute. That's not plus. 10 o'clock means 10 o'clock it start. And yes, the last point I told already first, because we can get the finance from Japan if you are using the technology. And this particular first corridor has been mostly 90% has been elevated corridor, because the land cost is covering around 30-35% of the project cost. So that width of that land requirement, if you elevate it, it is coming to 17.5. If you want to go with normal upgraded section means you need 35 meters. So that is one advantage. And the second advantage is safety, security, everything is fixed. Nobody can approach on the top. And that crossings of national highway and state highway, traffic will not be getting disturbed. It is going below. And the water also not a problem, because there is a river crossing. So elevated is, meter built, the initial cost is more, but the maintenance cost is less. Yeah. Now, this particular hallmark of this project is the full span box girder, 1,000 metric ton in single concrete element I told. How it is getting casted and how it is erected, that we'll see a 2-minute video. This is the mass shooting made for our Honorable Prime Minister. See them shooting, the quality of it. see the bottom, there is a rectangular hole on the edge. I'll tell you why. Thank you. And from this video, you might have seen we are not able to use, because first time in India, so we can't able to use robotic arrangement for reinforcement tying and bending. To some extent we could able to do it, but tying initially we was not able to do it. Plus shutterings are made up of hydraulic arrangement. So the later version was to reduce the manpower, which is the scarcity in this today's world. I mean today's the construction industry. So we are moving towards automation by reducing the manpower interference. Okay, so this particular 4 equipment, what you have seen is the mammoth in size and the capacity. The first set we have purchased from China. The next set we have made it by L&T itself in our in-house Kanchipuram workshop. All the straddle carrier, which is lifting the girder, and the gantry, which is lifting the girder from the bottom to top of the girder transporter, the 210 wheel girder transporter, plus the last launching gantry, how it is placed at the required location. This all 4 equipment. The second set was made by L&T under the scheme of Make in India. Yeah, now come to technology. The first, you know very well, the survey is playing a very integral part as well as primary part of any project, because survey is the very, very important, because based on that all the dimensions as well as line and level has been finalized. So when we are checking the initial level, we have used this LiDAR survey, that is light detection and ranging. We are used the helicopter, below the helicopter scanner with a drone, and at the fixed level it will be capturing 350 meters on either side, 700 meters, center is the project corridor. It captured all this level, and we could able to do it within 2 days. If you see that 90 kilometers survey by using the total station, even though if I use 10 sets, it would have been done 1 week or 10 days. But accuracy is the matter. But in this particular survey, the accuracy is very good, and it can give you a 3-dimensional details. And if it is a thick forest, also it can penetrate inside the forest. If you see that particular upsection is there, it is giving in red color, and bottom of the left to bottom of the presentation. And green, it is plain ground. And wherever water bodies are there, it comes with the blue color. This is the one technology we have used for this linear project. And the second one is, you know very well, the N value is deciding the depth of the pile. When L value is good, so we terminate the pile at that level. So normally what happens, the conventional method, the winch operator, if find out the blow, how many numbers which is getting in 150 mm, this 150 mm penetration, how many blows it takes, that fellow takes. But normally if that particular N value, which is the very important and vital data which play the role on finding out the bearing capacity, or N value means it is directly empirical formula says what is the level. So that is, in this project, Japanese has told we should not use it. So it should be used with the automatic hammer. So we designed one hammer and fix it in that drilling machine. So the normal, what you are seeing, the tripod is not used. It is a semi-automatic drilling machine has been used. When the project was started, it was only 5 machines available in this country. All the 5 machines were available with our competitor, Dilip Bilkan, in which 2 machines were operated by one of my friend in Ahmedabad. So I could able to get one equipment, but then slowly we have automatic and did this design in the local. Then that automatic hammer has been fixed. So calculated with very, very precise step method, so that our N value will be available. It will be available. It is not that it will be decided on the skill set of the bench operator. That is one thing. And second thing is, when that perimeter, that weight is 63.5 kg, and that particular fall has been fixed by that automatic equipment. It cannot fall high speed or low speed. That's same the frequency it will fall. That is this particular method. But nowadays it is already started in metros. It was in 2020-21. Sorry, it was first time. And second is then pile load test, whatever we are doing, initial load test. N value, when you are getting it, to check that N value is okay or not, we have to complete that initial test pile. That is, we call it as in construction line, destructive pile. That pile will be away from the alignment. That pile, once it is tested, that pile will not be rejected. That is called initial test pile. There we can always get the settlement. But the settlement, normally what happens, we used to do with the static load or cartilage method, which I, in the college, used to tell. But here what happens, we want to know that particular settlement, along with the settlement, how the pile is getting subjected to the screen friction when load is getting applied on incremental manner, 20%, 40%, 60%. How that particular skin friction is functioning at 5 meter, 10 meter, 50, every 5 meters you can take. But 30 meter means we used to provide around 5, this particular dial gauge. It is used to called transducer. So depending upon that expansion, this strain gauge expands, then automatically through the wire, we get the report, so that when the load is coming at 20%, how much screen frictions are available, 5, 10, 15, 20, 25. 30 is automatically your settlement. So normally when the load 80%, after that only you get the settlement, because the screen friction is taking care of that settlement. Okay, so our piles are mostly bearing. After doing this testing, we found it is partly end bearing and partly screen friction pile. And here one thing, when I will show it. In the reinforcement gauge, there is a pipe which is shown in the brown color. That is called a pipe. That is having 3 pipes of 50 mm and 1 pipe of 150 mm. That 3 pipes, through these 4 pipes, we used to check. So across the integrity of the pile is how it is in that total throughout the length. No whites. So white patch comes through that 150 diameter, then we normally happens what in between anything white patch means that the operator has removed that trimmy pipe because of choke or something. So new concrete and old concrete, something happened. That joint may be weak. But normally in pile, when we are stopping the flushing, reinforcement threading, then trimmy pipes, it takes around 2 to 3.5 hours. Then once again, we are not processing. There will be deposits. When the concrete goes in, that time this soft toe has been not properly cleaned because by the pushing of concrete, then there is a soft. This 150 mm diameter pipe, which will be useful for in, we will drill it and grout it, and we can strengthen the soft toe if the pile is having. Further, this pipe has been provided. And in case of this particular sonic pipe, if it is not giving any report, that they might not know doing with the soil reaction, because Kentledge is now outdated. So we are using only, take the reaction from the soil, so that we need 2 beams and some anchoring on the ground with using the HD strands, through which we used to do it. The second is now it has come to routine test that is dynamic. With the constant load, you put it on the top of the pile, how much it settles. That is called dynamic. And here, that M50 high performance concrete, because this is the, where this concrete is exposed to huge surface area, because that you see 40 meters and 3.8 meters and bottom meter is hollow also. So normally the shrinkage cracks comes because of there is a, in the inside of the concrete when the, that is OPC, obviously fly ash is not allowed as per the Japanese. So when we are using OPC, then the rate of hydration goes up. It will come through the other surface. That is the shrinkage crack. So what we have done, the first time we put a sensor, thermocouple, that what are you asking, that resistance temperature detector. We have provided on the surface, on the right, left to bottom, the box shape is there. There is a red color point. That is the thermocoupler we have provided, embedded in the concrete. And then after the concreting is over, then we started measuring the peak core temperature of the concrete. So this is the graph. First 72 hours, the concrete temperature is going up. Okay, then it drops down. On the 4th day onwards, it is coming down. So that means first 4 days, the strength takes place around 70-75%. But as per our construction technology, what you have seen in the video, the inner shutter is going inside. After concreting is over, it has to come out. It will come out once you complete the transverse trussing on the cross. So that will take 3 days. So we need to get the 3 days strength. Then only our cycle time will come down so that it will improve the productivity. For doing this, what we have done is, we know the temperature when it is going up. So how can you reduce the concrete temperature? Is 2 things. One is placing concrete temperature, you restrict it within certain limit by adding the chill water or ice cubes. That particular 2 ingredients is reducing the concrete temperature by 3 to 4%. And the next is, we reduce the OPC cement by replacing the first we thought microsilica. But microsilica, I will give you the next slide how it has not properly worked. So we went to the ultra fine GGBS. We replaced with the 30 kg of cement and we added, then automatically that peak core temperature has come down. Within 2 to 3 girders, we could able to find out how to produce the girder with 0 crack. So that is the first exercise we have done. Because we have gone through the journal in Chinese, we could not get any information about that. It is available in Chinese, but when you translate it, they were very, very, conservative, I can say that. They are not expressing their experience in the journal. And then we went to Taiwan. Taiwan is a semi-high-speed rail, so we could able to collect information. Japan was able to give something, but Japan cannot be compared with the Indian temperature, especially Ahmedabad, where maximum temperature goes 45 and minimum goes to 22, 23. The difference is 20 degrees in peak summer. In Japan, it is not like that. So a lot of things have been done, and we produced. And one more thing is from the environmental, sustainability point of view, by reducing 1 kg of cement, we could able to reduce 350 kilojoule of heat energy. So when I'm doing to 20 kg cement reduction, then 20 into 350 into number of girders. So my girders are 2,174 girders. Then imagine how much gigajoule we have reduced the heat of energy to this atmosphere. So now with this one, only I was telling, we added that GGPS. In all respects, whatever I don't want to explain because good wealth of people are sitting here as a student as well as experienced people. All the structural parameter what required for M50 concrete, we could able to get in GGBS. Plus, we could able to get 15 gigajoule energy has been saved. Yeah, one more thing, when this, another package, C4, civil package 4 and C5, C6, when we combined together, our requirement was shorter of OPC cement. But OPC cement, we could able to overcome Ultratech. Ultratech able to support us to some extent, Birla and JP. So we could overcome the cement requirement because when the project was started in 21, 35 metros was running across the India, 35 metros. Apart from that, all the states are doing lot of bridges, a lot of bridges. So there was a demand for cement, steel, and strands. We could able to manage cement and steel, and aggregate we are already having our own crusher, but we have struggled in strands because our requirement of the project is 1.5 lakhs metric ton total. The Indian production capacity is 1.5. Even I can consume in 2 years, 75,000. So 75,000 is 50% of the demand. So if he is giving to us, all these 6 players, then what will happen to metros and then road projects? So then we requested Tata SSL to open one more unit. So he could able to produce 6,000 metric ton per year. That means 72,000 years increased, because he's also had a market study that there is a supply and demand, so that we could overcome this one. Another one is in this project, since it is a Japan's aided project, the design was Japanese. So normally in India, we used to provide the seismic stopper at the edge of the structure, so that arrestor will shake, it arrests that shake which is due to the seismic effect. But what they are doing, I told you, in the video, there is 2 holes. So 2 holes, these 2 stopper will be getting, and one is on the fixed end, other one is on the movable end. So the movable end will be having a spacing so that the seismic stopper will move on both the direction, longitudinal as well as transverse, and the fixed only will be fixed. And where the bridges are having 180 meters continuous span, there we are providing damper stopper, which has been imported from Japan, 1.2 meter by 1.2 meter of height, 2 meters. Okay, that is the green color, green and pista. And this seismic stopper and movable stopper we have done with our L&T Azira. Rubber has been made from Kerala, and structure has been made by our L&T in-house. So there was a challenge. What happened that this top elastomer cover has to go inside, because if you see both are having that fixed as well as mobile, because this will be going inside the girder. So when the seismic effect comes, this is fixed. This will only move, so that this particular rubber and that stopper metal body has to have very good connectivity. There is no any gap. So that was the challenge. So because when the measurement, when we are fixing it as a hollow, when it is getting galvanized, what in our bearing language they used to call it as backing. When it is backing, your elastomeric bearing is made up of rectangular size. It can come with the rectangular size, but it is having hollow. When the size is getting not getting out properly, when we are putting it, either it's tight or loose. So then what we have done is, by doing some proper analysis on the raw material of the elastomer, then we made it vulcanizing. Depending upon the size, whatever available, then we change it to our steel body so that it go inside. So now you can see this photograph, this particular two, what you are seeing, the 2 things will be going inside the girder. Bearings are placed on the other side, and if that is the fixed end, and this is the movable end. Yeah, okay, that is now come to the top portion, because after that FSLM, what you have seen in the video, after that lot of things will be coming up. Noise barrier made up of precast, and every 40-meter expansion joint we have to provide one metal fencing made up of steel body, that metal fencing having the slots, so that due to thermal stresses, contraction and expansion should be allowed in that expansion of the metal fencing. That is shown in the red color. And cable duct, one is power and the other one is communication. Then evacuation barrier where the maintenance is going on. When the train moving at 320 kilometer speed, the people have to go and stand and sit behind the barrier so that aerodynamics will not affect, otherwise people will be thrown away. And so all the things are shown in the animation, but now the work is going on. Once the work is over, then I can able to see around 2-3 kilometers video, not now. And see this particular noise which is coming out from the bullet train which at 320 kilometers per under decimal. So under decimal is not allowed in India. 70 is for rural and 40 is for urban. So so now this to making this noise barrier, we could able to reduce 70, and by providing the polymer, the blue color what you have shown, that is the polycarbonate noise barrier above this concrete 1 meter, only available in the urban area, so that these two things will reduce it to 30 decibel or 40 decibel. And the rural area there is no polymer polycarbonate panel, so the 70 will be there. This is the way we have designed, and the train when it is moving, passenger who is sitting on the window side as well as aisle side, we can able to see the natural beauty of the thing, the way it has been designed. This barrier will not become a barrier for the audience or travelers. And sustainability, you see, we are converted everything into electricity, except few equipments, heavy lifting equipments, boom presser, transit mixers, all are consumes diesel. So far, EV has not come. EV has come only to 2-wheeler and 3-wheeler and small 4-wheelers. The EV equipments will come maybe another 5 to 6 years because this needs big lithium battery. So that is the one thing we are suffering now. Other than that, we have converted everything into electrical, and we could able to plant a lot of, there is 131,000 trees so far we have planted, and we are having solar panels, renewable energy, but it is not compensating my total carbon emission. So carbon emission will be, I can say, around 20% approximately is coming, but 80% our project is emitting the carbon monoxide. Okay, so but our company's carbon neutrality is 2040, we should able to give it. 2040 we should be neutralized. The land has been taken, and we know the precast yard, 45 acres, 75 acres, 80 acres, it became a white field. We have taken a project for green field, white field. Then once the project has been completed, giving that one you have seen. Same land before, after precast yard and handing over of that. And some of these things are old concrete, because when we are producing concrete, a lot of are coming. That we started using for making road. Our office buildings are not made up of brickwork or hollow. It is made up of prefabricated. It is having the energy conservation material. It can be reusable, so that we always use that prefabricated buildings. And in the road, we have used the geocell so that it can reduce the thickness of the road, which can lead to consumption of natural resources getting reduced. And people's strength is around 8,000 people, our project, the peak. So the 8,000 people, food has to be wasted. So now we are using to organic converter and compost. Okay, I'll move another 2-3 slides. Okay, so, and we have not used the curing compound. We are using only, we are not using water, we are using only curing compound. And all the boreholes has been converted into water recharges. It means all the boreholes we are converting into rain harvesting structures. We are having around 58 boreholes, so in future it will become a rain harvesting structure. We have a lot of digital initiatives. All the apps has been designed by L&T, from quality, safety, attendance, and you can see the progress monitoring and erection monitoring and equipment data analytics, how the equipment, the fuel has been consumed, geofencing, when the vehicle is going out of the fencing, then we can get the alarm. Lot of things are there, machine learning, you can call it as machine learning, especially IoT. So with that, with this lot of digitalization, we are doing it in construction. Okay, the second part I will, nowadays the students are not carrying engineers or engineers. They are not carrying the drawings or specifications. So we made it a QR. This can be read by only employees because you have to use your PS number and you can read it. That's how you cannot download it. In which the safety method statement, quality safety method statement, work method statement, bar bending schedule, and all the relevant data which is required for your day-to-day is in the QR code. We have done in our that GT is moving on the top because always there will be a vulnerability when the tire puncture burst, 200-ton wheels. So the 200-ton wheels has been monitored in the screen in the operator so that it can be stopped immediately. Automatically the vehicle will stop. Because anything goes wrong, then there is a villages or buildings are coming. That will be a, so that geofencing is also there. So while we already see announced in Ahmedabad. So in next is Olympic. Olympic is 2036. There's a competition between South America, no, Saudi and India. So most probably Olympic. So for that, this Delhi, Jaipur, Ahmedabad is must because at that time that Mumbai will be connected with Ahmedabad. Ahmedabad needs to connect with Delhi. The both are international airports. So that will be the first project what is we are pursuing as a professionals. The second is the political trend, the Delhi Varanasi, because of his constituency. And one more good viable project is there, that is Chennai, Mysore via Bangalore. But if the political trends happen, that project may come, may not come. But one more thing is that Delhi Amritsar. So like the 3 to 4 projects are in the pipeline. And I have traveled in Beijing to Shanghai. You see that how the person is walking when the 341 kilometers train is moving. Observe the water bottle. Just started, right? The outside temperature is 1 degree. The train is running at 341. It just started from Beijing. See the water bottle. My camera is shaking, but water bottle is not shaking. The train is running at 341. And see, one person is coolly walking. Even in aircraft also, we need to take a support of L. And see that how the smart cities has been developed at outskirts and how they are connecting the bullet train. Thank you. Thank you once again to my company as well as organization committee, sponsors, and institutional partners. And once last, as important, my audience, they were cheering me after having a video. I hope that video is entertaining and enterprising. Very important is enterprising. Okay, thank you, and Jai Hind.
Thank you, sir, for that insightful presentation. Your perspectives have truly highlighted the engineering ambition and transformative potential of this project. Our next speaker is Dr. Bimal Patel, Managing Director, HCP Design, Planning and Management, presenting the Central Vista Redevelopment, a project that is reshaping India's administrative core. Sir, the stage is yours.
What's the name of the presentation? Can I use this?
evening, everybody, and thank you for being here. And thank you for organizing and everybody, and Anal, and everybody at CRDF and at SET. Let me get on with the presentation so that we can then have the question answer session. So I'm going to talk about the Central Vista project, but not the Central Vista project as a whole, just the Parliament of India. So first, let me say something about, sorry, I don't know which side to look at, yeah. Sorry? No, I'm fine, I'll just stand like that. So I'll first talk about the Central Vista project, then design and construction of the Parliament House, and finally some words about the key challenges that we faced. Let's start with the Central Vista project. So the Central Vista, all of you are familiar with, it was built between 1911 and 1913. Excuse me. Is that okay? It was built, Central Vista was built between 1911 and 1931. It's at the heart of New Delhi. It was meant to be the living center of administration in India. Of course, that meant that it was the British Raj, and it was supposed to be an architectural icon for the British Raj. So here's a drawing of a map of Central Vista in 1930s. And this area with the black line around it is referred to as the Central Vista area. It was an icon for the British Raj. If you look at the design of this area, one simple way to think about it is that it was a sloping terrain that was here. And this sloping terrain, they made a platform of this sort at a height. Then there was a grid of streets that you can see. Excuse me one second. Do you have a collar mic? If you have it, bring it, then we'll shift to that. So a grid of streets here. There were formal gardens around this area and tree-lined avenues that made up this place. Originally, it was imagined that there would be so many different buildings here, and these would be administrative buildings and government buildings. But in 1931, by that time, the power of the Raj was dwindling, and so only the following buildings got done. So architecturally speaking, it was essentially a grand boulevard. This was in keeping with the kind of projects that were being done in Paris, had been done in Washington and Paris. And so it had a gateway at one end. There's an axial processional route, so that from the gateway you come up, you're going up that axial route. There's gardens on either side. There are important nodes on the way. And then there's a focal point at the far end. So that's sort of the architectural sort of, yeah. Yeah? Does it work? This is right. Okay. I prefer standing this way. Yeah, so you have a focal point at the end. So that's the gateway, India War Memorial, as it was called at the time. This was the axis, nodes along the way, administrative buildings on the two sides. This is what Lutyens imagined. It's the architect of the project. This was the focal point. This is the Viceroy's Palace. And this is what got built in the early 1930s. This is what it looked like. And that's a map that I've already shown you of this. It was a spectacular architectural achievement. It was built to house a colonial government, but when India became independent, it was appropriated by India's government and the people of India. Here there are images of when, during independence, Mountbatten leaving, flag of India coming up. All the people have taken over this place. And you can see here the Viceroy's Palace became Rashtrapati Bhavan council house, this was council house, there was never a parliament before that, became parliament. And the administrative buildings of the Raj became the administrative buildings of the ministries of Government of India. And certainly the Kingsway, that was a path in the middle, and the Queen's Way became Rajpath and Janpath. So this is the legacy that we got, but almost immediately after completion, and particularly after 1960s, the Central Vista was added to and managed in a rather insensitive manner without paying any attention to the comprehensive architectural vision that Lutyens had given it. So you can see here already in the Second World War, there were barracks built. This was stables and barracks for the war effort already being used like this. And as Delhi grew, you can see on the left-hand side 1942, and as Delhi was growing, administration was growing, more and more building got added to the original place. So what used to be this was the legacy, and it became something like this. So this was in the the late 90s, so early 2000s, but this is what it was by this time. So what had been a grand architectural vision got converted into a sort of a plotting plan where plots were carved out and given to different ministries to build buildings. When we started the project, it was still a magnificent architectural icon. It was a seat of the Government of India, the main thing that we associate with the Government of India, main architectural icon. It's a heritage asset, it's civic space for the people of Delhi, and the most visited tourist destination in Delhi. But it was a hodgepodge of ill-matched and incongruent activities. You can see residential buildings, administrative buildings, legislative facilities, all sorts of things mismatched here, and that was the kind of mess that this had turned into. More importantly, many of the plots had the same old barracks and stables, and these were still functioning as administrative office in the middle of Delhi on the most precious piece of land there. The public access, public space in the middle of this space had diminished considerably. You can see here. This was all that was, the green was all that was truly accessible to people. The architectural character of the buildings that were added here was sort of a mix, incoherent. So what had been a grand vision had been turned into an incoherent vision. If you look at the offices inside, they were in pretty bad shape. You can see this is the main offices of the Government of India, and they're not in good shape at all. Gardens were very, very poorly managed. The landscape was very poor. And you can see poorly managed streets, inadequate pavements. This was still a place for the Republic Day parade, but the infrastructure for this parade was every year built and taken out, built and taken out. It was sort of quite a mess. And there was inadequate facilities for tourists. It's the last biggest destination for tourists, but only one toilet in 3 kilometers. So it's not a really good place to go to. So over decades, many people, many institutions had demanded that the Central Vista should be better administered, it should be better developed, should be, a lot of people had talked about this, but it's only in 2019 that the government finally got down to refurbishing the place, redeveloping it, and rejuvenating this architectural icon. So this is a very important space for the country. And so this is what we had inherited. This is what we had made of it by 2019, and this was the master plan that was done for it. Now, I'm not going to talk about the whole master plan, but it essentially talked about creating a lot of new facilities, tearing down old buildings, improving public space, improving the heritage assets, etc. If you look at this, this is a sort of an aerial view of it, and there was a number of projects that were part of the large Central Vista project that was imagined here. Now, I'm not going to talk about all of these projects because that's a lot of different projects, each one very significant. I'm going to talk about the Parliament House. That's the key, one of the key projects here. So when we started work on Parliament House, the design commenced with study of the old Parliament building. And as you all know, this is where the existing facility was. And we looked at old drawings. So the round building we are familiar with was not the only design that had been considered originally. It was a rectangular building and this star-shaped building that was considered. But and this, by the way, these buildings were designed by Baker, not by Lutyens. Lutyens wanted the round building, and so that's what got built. Anyway, these were studied. We also studied old images, archival images. This is the central hall. And we also pulled out old drawings. You can see on the left-hand side. I mean, don't have in India a culture of maintaining good drawings. So all of them had to be drawn up once again because there was no single drawing available of the old Parliament building that we could use. We then had to go ahead and list all the facilities that are in the building because everything was in there, and people managing the place knew it. It was in their head. But you are familiar with this idea that there's not a single map that tells you what is where in the old Parliament building, so we had to go and map it. We had to map the circulation routes. Everybody knew the circulation routes. The whole place was functioning, but you didn't have a single map that would give you security arrangements, etc. So the first job was to study this building. Even the space utilization, what is in which room, what furniture is in there, how many people sit in there, all of this all the data had to be gathered first before anything could be done about this building. We also went ahead and measured all the furniture because we knew that later on whatever we make will be measured against what is already existing, and so we needed all of these things there. We surveyed the additions that had been made over the years, and you can see here on the image on the right-hand side, that entire, above the speaker's chair, the entire press gallery was added later on. So it was not as if this was Baker's building that had continued right through, but it had been added to quite a bit. We also studied expansion possibilities. Baker's building was designed for 150 Maharajas and princes to sit in. It was council house. But you can see here the columns at the back there. Behind there was a corridor which has also been filled in with seats. And so in a hall that was meant for 150 people, they had packed in 540 parliamentarians. So there was really no possibility of extending and increasing number of people in this hall. And of course, with the going forward, India is going to increase the strength of the parliament, and so expansion was a key issue that had to be dealt with. But it was quite clear you cannot expand this existing facility. We mapped the additions and alterations. You can see this is the kind of scenes inside. All the red color on the map is all the areas that have been altered. Verandas have been covered, people sitting in the verandas. It was jam-packed, stressed beyond belief. Over the years, the facility had been used extensively and added to. If you see the offices inside, they were quite a bit crowded, if I might say so, and they were quite difficult to get. I mean, that's the top office of the country. You see the communication equipment, plumbing equipment. We go ahead and make fantastic buildings, and we go ahead and then butcher them by all the additions that we do. Really, we have no culture of how to use buildings. All the equipment, audiovisual equipment in the parliament looked like a third-class compartment of a train ka dabba. You could see that kind of quality to it. It's old acoustic equipment. It's impossible to switch off mics. And the key thing we were told by the speaker was, I should be able to switch off the mic of the person. So they couldn't switch it off, so people could be rowdy, etc. Earthquake safety was also not. It was difficult to ascertain because the drawings were not there. So nobody could tell you how safe this building was. So anyway, the conclusion of our study, because we started out by saying, can this building be expanded? Can it be reused? Conclusion was it's a much valued facility, symbol of our democracy, but now it's not going to work. We are going to have to build a new building. Okay, so we decided to do a new building, and it was, of course, there was a plot, triangular plot, right next to the old Parliament available there, which originally was a garden but had been converted into facilities for security staff and reception hall and parking and air conditioning equipment. And so we said, if we cleared out this plot, there is enough space to build a new building about the size of the old building. And so that's what was designed on the two sides. As you can see here, this is the two buildings. It's a diamond-shaped plot. The two buildings, it was imagined, will work together. The old building will continue to be used. It was in use a few weeks ago for the Constitution Day, and it's surrounded by roads on all sides. The design started with some concepts, and like all design processes, there is a lot of iterations that one has to go through to arrive at the final design. And so here you can see, the various versions that got evolved as we went along. The facade also went from one to the end, and many, many versions were done, and many were thrown into the waste paper basket. Buildings like this, we were clear, have to have a strong underpinning geometry. I mean, these are iconic buildings, temples, Parliament, the Rashtrapati Bhavan. And for this building, it's laid on a triangular grid of this sort. The entire building, all the walls, everything falls on a grid. It's when it sits on a strong geometry of this sort, it has a certain gravity that you will never get with a building that doesn't. So this is how all the different parts of it come together. Everything falls on the grid. Of course, we had to try many different alternatives. Once we said, okay, can the triangles be 5.5 meters? Another one 3.5. Finally, we found that 3.65 meter triangle. This is like an aesthetic search for the perfect grid that will help you do this work. So you can see here, that's the basic arrangement. As you can see, and the three vertices, there is the ceremonial entrances. On the perimeter, you have the offices for the parliamentarians. The green is the Lok Sabha, traditional color for it. Rajya Sabha is red. And on the right-hand side, you see a courtyard and the central lounge. In the middle, we have a ceremonial space called the Constitution Hall and Gallery. So let me just run you through the building very quickly, just give you some sense of what the spaces were like. And so here you have that area is all the Lok Sabha area. I'll go into it in a little more detail. That was the rendering of the design that we finally made, and that's when it was finally built. So that's okay. And you can see here the speaker to the right-hand side. You can see the visitors' galleries and the horseshoe-shaped seating. That's the view from where the speaker sits, and you can see this. This is the view all around. And from the visitors' gallery, when you look down, this is what you see here. That's the front row. You can see that's the seating for the front row people. The Rajya Sabha is in the other corner. And here that was the sort of rendering of it when we started. That's when it was built. You can see here same idea, looking up, and that's from the visitors' gallery, what you see down there. That's the jalis on top that brings in natural light into the hall, and that's, I'll talk more about this. That's the lobby outside, so when you walk out of the hall, that's the kind of lobby that you see on the sides. The third important space here is the central lounge and courtyard. You see, the old Parliament had Lok Sabha, Rajya Sabha, and a central hall where they hold the joint sessions. The central hall where they hold the joint session was also used as a lounge. Everybody met there. It wasn't the most comfortable lounge because there were, benches. People used to sit in benches and have their chai and chat, and this was a really important place. So we decided not to have a special hall for the joint session, but to design the Lok Sabha so that Rajya Sabha members as well as big enough so that they can all sit together in the same place. You don't duplicate a hall just for the joint session. But the lounge becomes the third important corner of the parliament around the courtyard. And so we said there'd be a courtyard, open to sky courtyard in the middle of the building. And you would have that's when it was finally built. And you can see all around, there's basically the library and the cafeterias and the dining hall and everything here. So this is the place where they all can get their food. So that's a rendering of the corridor, and that's what was finally built here. And you can see here, that's the library that was done. The reading room is really a reading room for them to sit. And that's the central lounge, the cafeteria. And there are many there because there are quite a few people there. On the perimeter, we have the minister's offices, and that's a rendering of it, and that's the offices that were built. So quite intense set of facilities. There were also, I'm not going to take you through all of it, but there were also things like committee rooms on the first floor above the entrances. That was a rendering of it, and that's what's built. The parliamentary committees are a very important function there that has to be housed there. In the center, we wanted an evocative space that would symbolize the parliament, and India's constitution can be kept there. It's a large space, full height, and this was the Constitution Hall image, and that's when it was built. This is where the Constitution is placed, and this is where people come and visit. In the middle, we had this Foucault's pendulum that sort of marks the passing of time. You can see here, this is where the Constitution Gallery is. The Constitution is kept here, and that's what it is. There's a small exhibition about the development of democracy in India here. And this is the ceiling. There's natural light coming in from top. And as I said, so that's when it was finally built. And that in the middle is a pendulum that's swinging and sort of giving the place some peace, and gives a great sense of peace and quiet. And that's the pendulum that's been built here. The chamber, let me take you through a few details about the Lok Sabha chamber. The layout you can see here, that's the old and the new. One was small, just had 552 seats. The other one has 770 seats. The yellow is the hall. It's much larger. Administrative facilities are similar in both sides, and there's facilities for emergency evacuation here. Of course, for the layout, we studied many different possibilities, but everybody's comfortable with what we have, and we said there are different ways in which parliaments across the world sit. So I'm giving you glimpses of the kind of things that were thought about, but India, we decided let's stick with the horseshoe seating that we have, and this is what we finally did. Many small things had to be taken care of. In the old parliament, the sight lines weren't clear, which means that the prime minister and head of opposition, if they look at each other, then the speaker's head is jutting in between, because that was not meant to be a parliamentary hall. So here, we had to show that this is all possible. The speaker sitting here, the secretary general sits there, and you will all be able to see each other. The people sitting in the middle have been lowered down. So, so visualizations had to be done to show what you will see from the different places. And you can see here that the speaker is there, the secretary general, prime minister right across. And we also made 3D printed models like this to really show, because in a project when you want to explain things to people and you to get decisions, best thing to do is to show it to them in a way that they understand entirely and totally what they're getting. And so that's the final version of what got done there, and that's another view of the same thing. And that's another view of the Lok Sabha chamber that you can see as you enter head on. In such buildings also, symbolism is very important. I mean, that's not something one has to deal with in many buildings, and also not in many simple buildings. But here symbolism was very important. This has to become a national icon. And we basically decided on a scheme where the different spaces would be, after national symbols that we have. So the aesthetic theme for the Lok Sabha was the peacock. It had to be green because traditionally it is green, and luckily for us, we found in the list of the national bird is a peacock, and you can make peacock green, and everything works. So everything was sort of woven into the different parts, the interior of the building. And you can see here the ceiling of the Lok Sabha chamber is also sort of based on the theme of a peacock. And here you can see a rendering of the same ceiling. And actually the ceiling is like this. There's huge concrete beams on top. The structural designer is sitting here, Anil, and from it hang these this sort of false ceiling that has been created here. There's and you can see that's the infrastructure inside the false ceiling, the air conditioning inside it. And this is then finally the wooden ceiling comes up here, and that's the whole ceiling. Here's the structural engineer looking at the construction there. The building was constructed by Tata Projects, tremendous effort, and you can see here checking things out. And the ceiling, this is the wooden ceiling of it, had to be mocked up elsewhere. The mock-up was done first, and then it was built here. You can see that the ceiling is being put into place here. Of course, this is on a scaffolding up above. You can see in the hall, the whole ceiling being constructed here. So it's a humongous effort here, and that's what finally got done. But you have a peacock ceiling on top hanging from the top here. And that's another view of the same arrangement. Yet another view. So that's the symbolism carried through. The carpets have peacock on it. This was the interior designer, Kena Patel. She worked on this. And this is the carpet. The pattern of the carpet was selected from amongst all these different things that were considered. So you can see at one level it's all space planning, but another level it's a lot of tiny, small details of this sort. Here's the size of the, of the motif that you would have here, the different colors. I don't understand this too well. There was a huge team, and I'll tell you about the team later on. But here, this is, the carpet mock-ups being checked out. And finally, the fabrics for the seating were designed by a Bangalore designer. She worked on this, and very special textile, so it's very tough and will last for a long period of time. Here the benches, you can see the textile here, you can see that. And so the motif is carried into the seating as well as in the carpets, as you can see here. The jalis on top provided another place where we could do peacock motifs, and this was designed by a Delhi-based designer along with our office people. And here are the mock-ups that we tried. Everything had to be mocked up to check whether this would work or not. You can see here, this is the, it's all wooden. And the inlay work on the furniture, brass inlay, was also used and also used a sort of a peacock theme, as you can see here. And so that's what this is. And those things are taken into the woodwork and the flutings, etc. So that's that. So that's the architectural symbolism. The furniture, the building has many different furniture items, but let me just talk about the seating. The most important thing was where the parliamentarians were going to sit. And the original hall had bench-type seating. Very few people had desks. The seats were pretty tight, and so we decided to improve on all of these fronts. Everybody would get a desk in front, and instead of walking, if you have a bench, then you have to walk in front of people to get to your seat. We decided to give a space at the back so that people go from the back and they could sit. Also, we had to design it so that a seat for two people would hold three when a joint session would take place. So these were considerations. So you can see on the left-hand side the original existing seating with table, without table, and what we decided was revised seating arrangement. You can see on the right-hand side. You can see that between the one person's desk and another person's chair, there is space, so you can go from the back. This is what the furniture design This was done by Ismat Kambata, and that was the entire furniture for inside the hall was designed by her. And there too we have peacock motif, peacock fabric, and its audiovisual equipment, etc. We had to build mock-ups of this sort. This girl here, Dwani, who worked on the parliament, she CEPT graduate, by the way. She's checking out whether there's enough space to move at the back, and there wasn't enough space, so we had to change the whole. That was the final mock-up done in Ahmedabad, taken out there to Delhi for review by all the parliamentarians, and here you can see the speaker checking out whether his seat is okay or not. I'm trying to explain to him that isse zyada jagah nahi milega. Then this also needed acoustic and audiovisual technology. We used German technology here, so that, and the acoustics was very important because essentially this is a hall for people to talk, and the entire voting system and acoustic systems had to be done and fitted in here. This equipment all came from Germany, and very complicated circulation routes. When you have ceremonial functions, the president, prime minister, various people come in, and you have to arrange so that all of their motorcades can come in and park, deliver them to their proper entrance. And even within the building, the circulation routes have to be kept so that, there's separation between people, etc. So all of this had to be also done. If you look at the sections and facades, that's the section of the old building compared with the section of the new building. You can see it's more or less the same size. We wanted the two buildings to sit right next to each other and be comfortable with each other rather than fighting for space. And so they're similar sized. And we studied the old facade extensively so that the one next to it would be in harmony. We were quite clear we didn't want them to be identical. We weren't going to take the old one and copy it, but we also did not want them to be completely different. So, they're like cousins, if not twins of each other. So these were the various studies for the facade that were done. You can see here lots of models were made to figure out how we would, what would work, what would not work. Here's the selection of stone for the new building. You can see it is being done in front of the old building so that the two stones would match a bit, and that's you can see here. And that's the facade that's now quite familiar to everybody in the country, and that's the other side of it. So when you look at it from the side, it looks, from the triangular side, it's the other one. And so that was the rendering that we did, and that's when it finally got finished. Okay. And that's the rendering, and that's when it got finished. And that's a lot of fine detail here, lots of decorations picked from all across traditional architecture of India here. The jali that you see on the outside also quite elaborate to manufacture. You can see the mock-up here being tried out of the jali. And that's the corridor on the outside, the jali, and the jali can be seen here also. Of course, this is all what you see on the outside. Inside there is, like in a good car, when you open the bonnet, you see inside the bonnet, it's impossible to figure out what's in there. This building is also like that. That's what it looks like from outside, but if you open the bonnet, that's what you see inside. So there's vast amounts of infrastructure in there, and there's lots of piping, wiring, cabling, all of that. Yeah, I'll finish in a few minutes. So there's tons of drawings that have to be made, general arrangement drawings of this sort, details of this sort, false ceiling drawings. It's a huge drawing effort. Structure, HVAC, furniture. That's the speaker's chair, the drawing for the speaker's chair. It's quite elaborate. Tender drawings. Lots of tender documents. All the tender documents have lots of pictures to explain to the contractor what you're going to do. This is a unique building. It's very difficult to specify it. Lots of new items here, etc. Let me run through the key challenges that we faced. The key challenges they were met by a joint effort of the client, contractor, and architect. Client being the Ministry of Housing and Urban Affairs and CPWD, our official clients, and the contractor, Tata Projects, and architects. In the morning, Malay said that unless everybody works together, you can't make a project like this work. And really, if you see it, it's testimony to everybody working to make this happen. Also, let me say what I'm going to say is mainly from the architect's point of view. If you ask the contractor, they'll talk of other constructional challenges and other such things. I'm just going to quickly tell you about challenges faced by us, but that we worked all together. First of all, it's a politically contentious project from the beginning. Okay, so everything was questioned. Whether a new building should be made, whether, when it should be made, how it should be made, everything is questioned here in the press. And so one of the big things was for us to help the MOHU in answering specific press queries and parliamentarian questions. So that was one of the jobs that we had to put in and give data sheets, etc., that would help them. The project had to be explained in public forums. Here is me giving a presentation of this sort when the project was most contentious and explaining to people what this project is about. We also created a very special website that would give all the information about the project. So that's the Central Vista website. We created brochures of this sort. We created comic strips like this at one stage. We were desperate to get the message out that this is a sensible project, man. Don't turn this into a political football. And that was what it had become for a while. There were multiple court cases that had to be handled, and while most of the work was done by the government, our job was to, there were court cases in Delhi High Court, and there was a finally the Supreme Court got into it. It took 1 year to clear all the cases, but our job was to support the Solicitor General with real information, because the project had a rationale that was being distorted by the petitioners. There was an unusual amount of statutory approvals in Delhi. Delhi is the most regulated place in the world. Normally when you go, you have to take a building permission, a fire permission, something else. But in Delhi, you have so many more permissions to take. And guess what? Central Vista Committee, which had been existing since 1950, to manage the Central Vista, which of course you can imagine how it has been managed, unka bhi permission lena hai. And we have Delhi Urban Arts Commission. They will tell you things about your building and tell you, I don't like this color, I think this should be like that, etc., etc. I mean, they have a job to do, but you can see I'm on the other side. So there are many, many permissions to take. So managing this with all sorts of applications, all sorts of persuasive presentations and going up to them, and finally, sometimes making compromises without losing the integrity. I mean, the challenges for an architect is very simple. There's only one challenge, really. The project like this is complex. There'll be many, many problems. Many things have to be faced. Your real work is to ensure that the building's design's integrity does not get destroyed in the bargain. Finally, what comes out shouldn't be a khichdi because so many people, so many problems were there. And that's your real challenge for the architect side. And of course, it works only if the contractor and the clients are all working together to ensure that the integrity of the building remains. There's multiple owners. There's no one owner of this building. Rajya Sabha, Lok Sabha, Prime Minister's office, security, tremendous number of the Ministry of Parliamentary Affairs. All of them have veto powers. And all of them can come up with late-stage requirements. And so there are 37 agencies to deal with and to find out from all of them whether they are okay with what we are doing. This includes Sansad TV and National Informatics Center and Lok Sabha Secretariat, Rajya Sabha Secretariat, and everybody. That has to be satisfied. Sometimes I wish that I had to, my objective was very clear, that I had to run a train for 82 kilometers at 320 kilometers per hour, and that's what I got to get done. Here it's like everybody has to be accommodated. Well, how do you do that? First, by first you know all your existing facilities. You have to map them. You have to be able to tell them कि आपका room वहाँ तो इतना ही है, इधर क्या मांग रहे हो? So all that measurement is what is. All those studies, initial studies, were very, very useful, and they helped bring. I don't blame them. People usually don't have a sense of how much space they are using. So if you ask them, what size library do you want? They say, yeah, 50,000 books maybe. 50,000 books, CEPT library has 30,000 books. I don't think you need that many. So you have to bring rationale and reason into the discussion, and the way to do it is to bring data to the table. You require, you have to keep designing and accommodating requirements, and that's how the thing works. Meetings, you got to keep meeting people and stakeholders. You got to keep a log of all the meetings. You got to have minutes. If you bring some order into this process, that's the only way it can be managed. And you have to communicate data very clearly. Here's something saying that this is the amount of space you had in the old building. Here, color coded to show what you were enjoying earlier, what you enjoy now. All of that tabulated, room-wise, people-wise, and finally, there are sort of interdepartmental wars. So also saying, isko itna mila, isko itna mila. Also accommodating all sorts of late-stage requirements. We started out when the visitor gallery with 288 seats. I said, we need more. We need more. We need more. Finally, we had 480 seats in there. So you're constantly revising the design, but you're revising it so that you don't lose the integrity of the. Extremely tight timeline was the key challenge, as you can see here. The building started, concept design started on 11th October 2019. You can see here, it was finished in 3 months. Schematic design started after that. Then the foundation, then parallelly we were doing local authority approvals. You can see that's a big chunk. We were also doing tender documents, construction drawings. Construction drawing details came afterwards. Then the foundation stone happened, and construction happened over 2.5 years. And finally, within a period of 3.5 years, we finished the entire process, starting from day one to do this. The only way for an architect, from an architect's point of view, intense communication between site, client, contractors, constant communication, because this is a complicated building with lots of different things, lots of requests for information. We had 12 people on the site on a daily basis maintaining a contact between the studio and the site. You can't do a building like this, just give the drawings and go on a periodic site. It doesn't work like that. Constantly giving snag lists and reports, pointing out where things need to be improved. 5,500 observations. Lots of early mock-ups, because you want to do a sample first, then do the final thing. All this is furniture mocked up in Bombay, because the contractor was from Bombay. In his site in Bombay, it was mocked up. This is the ceiling mocked up in Bombay. You can see this is the facade mocked up on a site outside of Delhi. Jali mocked up elsewhere. Everywhere, entire rooms, because we were repeating minister rooms, so entire minister room was created elsewhere to be able to do this. All the pieces of furniture are mocked up and tested to see whether they are okay or not, and then you give the go-ahead for that. Many mid-course corrections are needed. For example, we had been ambitious and said we have to use L-shaped stones in corners of lots of. You can see here on the left-hand side, the stone is a continuous stone around a corner that gives the building a lot of, it makes the detail different. On the right-hand side, you can see it has been revised to a chamfered joint. There were so many places where there were L-shaped stones, and then we turned in saying, okay, itna nikal do, because we need to, those sort of compromises that will help it get done on time. For the best of intentions, there's going to be construction errors on something, and your job is to accommodate it in a way that it does not destroy, once again, the building. So here's the column casting had gone off by a few centimeters. You can see the drawing below and the casted thing. So so the jalis all have to be a different size, and how will you change the pattern so that the jali nobody can make out afterwards. We also simplified things sometimes when there was brass asked for, and then we said, no, let's turn it to stone because this will be faster to construct. A most important challenge was working through a pandemic. Okay, during this period that we were working, this much period was the pandemic. And the only reason why we were able to do this is because of online technology. We were entire building was designed, you can see here, the entire building was designed, the schematic design, everything was done through lockdowns, etc. Everybody was in their homes. Our whole office was operating from their homes. And you can see here, these were periodic meetings, trying to figure out, these were sketches being discussed of what we are going to do. There were drawings being discussed like this between consultants, different parts of the country, and construction drawings also being done. And the outcome, as you can see, is here. So finally, we have the two parliament buildings. That's the two sitting next to each other. Here's an image that is now quite familiar, and the Lions, which also had their own controversy. And here's the parliament finally in use for the joint session. Here's another view of it, here and here. As Barjor mentioned in the morning, none of these efforts are doable by one or two. I think Suren mentioned that it's large teams of people working, almost 300 for the design effort. Okay, construction has vast numbers, but we were principal designers. There were other people attached with us, hundreds of people working for 3 years, 25 consultants coordinated, structural, electrical, decorative elements, etc. It's everybody brought together. Thank you very much.
Thank you, sir, for that insightful presentation. Your perspectives on the Central Vista redevelopment have offered us a deeper understanding of the design vision shaping India's administrative future. We now invite the speakers on stage and open the session for questions from the audience. We are taking a quick drone shot, requesting all not to get bothered and look at it. It will just take a few seconds.
Social media. Sleep.
Free to raise your hands. Yeah.
Should I wait for the drone to pass by or?
No, it's
begin?
okay. We can start the session.
Okay, I mean, I think this is a very, I think the summary has been quite focused. One thing I want to share, perhaps also bring in a question for you all, is that it's just above my head. I can barely hear myself. Yeah. I already had a haircut a few days back. Is it? Okay, quickly. What we noticed in the last many presentations, in fact, almost all of them, 8 projects, whether it's funding, expertise, technology, or even products, whether it's Kempegowda Airport with SOM Design, Navi Mumbai, Zaha Hadid, Bullet Train, JICA, Kishanganga, Halcro, Mumbai, JICA again, Aegis comes in from France, Zojila is by SMEC Australia. The last one was Indian in that sense, right? So the question I have in terms of what do we need to do to augment our capabilities and capacities to deliver these projects at the largest level and perhaps the most expansive level? Because whether it is machinery, equipment, luggage handling, lighting, design, engineering, consultancy, we are taking in a lot from global enterprises, multinationals, if you want to call them. And it's a question to Bimal, because the last one was designed over here and perhaps even engineered over here. So, thank you.
Is that on? Yeah. May I? Yeah. Let me say, yes, you are right. India today, I mean, it was, first of all, it was wonderful seeing all these projects. I didn't see all of them, but I saw 3 plus. That India is on its journey to started its journey to do these sort of projects. And truly, India's problems are not going to be solved without thinking at scale, building vast infrastructure, and doing the sort of things that L&T and various other people are into. It's also very clear, as you say, that India is stretching. It has no capacity. It doesn't have the design ability, doesn't have sometimes the construction. But we are stretching and pulling and trying to improve ourselves. This is going to be the story for the next 2 decades. We are going to have to truly push ourselves into doing all of this. And you know, if I think about it, the most important thing we need to do to be able to meet these challenges is to get out of the mindset that we had been in for the last 30, 40 years. Let me just say a little bit about that. See, when we became independent, the dream was clear. India was going to had thrown out colonial masters, and we were going to become wealthier, and we are going to solve our problems and win respect in the world by becoming people who are able to solve their problems. Unfortunately, because of the prevailing ideas at that time, we took an economic route of socialism that really made us poorer, did not make us richer. Over the 60s, 70s, India's economy was stagnating. We were making no money. We were becoming poorer by the day. And sadly, some of those years, I'm a little bit older than you, so I lived through the 60s, 70s, 80s. During that period, India's people got convinced that we will never escape poverty. And if you look at the professionals of India, including the people, many of the people who used to be very much part of CEPT and had this scarcity mindset. India can never escape poverty, so let's figure out how to do things small, how to improve how to help poor people, but without really escaping poverty. So you had all sorts of efforts like, let's make the cheapest building possible, let's use appropriate technology, let's not disturb nature, let's do community projects, let's do this. That's not going to work. It has never worked. We are going to have to build wealth. And to build wealth, we will need, as he said, we'll need infrastructure. And we have to build wealth by changing our mindset and saying that we are going to have to transform our economy, we have to transform our infrastructure. Now, faster India gets out of that scarcity mindset, which I believe still plagues a lot of professionals, and a lot of thinking Indians are still very, very conservative and in the scarcity mindset. Unless we get out of that, we are not going to be able to start thinking in the way engineers in L&T are thinking, or in the way that people at Adani Ports are thinking, that we got to build the infrastructure, we got to take on the big challenges and do it. And I can tell you that once we decide, we will be able to, but we have to decide to do that, and that's not happening. Sorry for the long answer to a short question.
So what I understood from you, that project financing, why India could not able to stand on own, they are depending upon the outside. That is your question? Okay, now capacity, if you see...
it's not only financing, it's expertise, technology, products on multiple fronts. The question is, what do we need to do
Yeah,
to build, I mean, we're an educational institute.
So I will go a little bit deeper from Sir answer is, see, I am working in this particular infrastructure, especially roads, railways, and now high-speed rail from 1992 in L&T, the 35th year. If you see 1998 onwards, India is having, except the 13 days Prime Minister of Vajpayee because of late Jayalalitha. If you leave it from that 1998 to today, this particular India is controlled by a good Prime Minister, Vajpayee. After that, Manmohan Singh. After that, Mr. Narendra Modi. So if you see particular what infrastructure I am looking after is, in 1998, we were not having project financing. If you remember that diesel price has been increased by 1 rupee, that 1 rupee will be going to construction of road, the Golden Quadrilateral, that 4 cities has been connected. And then next is north-south, east-west corridor. Then Mr. Manmohan Singh came. Then he developed DFCC, Dedicated Freight Corridor. Then Mr. Modi came. So what I'm seeing from this last 2.5 decades, India is having the money to fund it. It means because our defense expenditure is little bit is dropping down now. So definitely that whatever that collection of GST is coming, there is a good volume of money is available. It is not shock to me. One of the project of high-speed rail will be financed by Indian government. We don't want to have, I'm not talking about all the 3-4 corridors, that is 1,200 kilometers, at least 400 to 500 kilometers project of cost 1.5 lakhs crores. Definitely Indian government can able to spend in the 5 to 6 years. Parallelly, the technology and expertise, experience, everything is also skill set, everything is growing along with that infrastructure growth.
I'll come next.
I have a question for Bimal Bhai. Since there are multiple stakeholders for this type of prestigious projects, how the design approvals take place? How means it must be very exhaustive. And there is a second question. Okay, first let me understand the answer.
So, this is a particularly challenging project, but architects have to deal with multiple stakeholders all the time. And you have to try and find a common road between all of them that will be useful for all of them. When we design bungalows, often husband, wife, kids, they all think differently. And you have to deal with all of them. And if you don't satisfy all of them, so your skill is in figuring out a design that works for different people, really speaking. And here it's a particularly more difficult challenge because there are larger number of people, and in a family or in a company where you go, where there are many departments, there at least the main boss can tell everybody else to shut up. Here there is no such main boss because the building has 3 owners, and all of them will protect their sovereignty. And so really that's the job.
And especially when there is no main boss, how does it happen?
Yeah, that's the job. Your design has to be such that it will meet different people's requirements. That's it. You can't say, let's disregard one or the other. So I'd say it's a particularly challenging case of what most architectural designs are about in any case.
Yes, sir. And there must be a team of designers and some vision of designers. So how much could you achieve at the end in terms of, because of the approval and the construction? So are you happy about that?
Are you happy about what came up? Yeah. I think we managed, with all the challenges that were there, we managed to retain the vision of what we set out to do. And that's really why the project is successful. If it had not been for me, it would not have been for everybody else either. That's really the measure.
Good afternoon, sir. My question is to Mr. Mohan. As you said about that box girders, so for curve alignment, do we consider monolithic box girders or segmented box girders?
See, in high-speed train, when the train is moving at 320 kilometers speed, the radius will be more than 6,000.
Okay.
Okay, so what you are seeing that where the metro is moving or road bridge is moving, that sharp curve will not be there. So in our corridor from Ahmedabad to Mumbai, only one station is running parallel to the existing railway station, that is Vadodara. Because I asked the people why Surat, Bharuch, Anand is away from Nadiyad, maybe by 10 kilometers. So if you see all the stations are away from that except Vadodara, so they told one convincing answer because the passengers which is coming towards Ratlam or going towards Ratlam will get this thing. That station would have been done even the outskirts also. So if you take out that particular stretch where the train can move up to 175 kilometer speed, 175. So there the segment has been made it as a segmental. Segmental means what you are seeing in the metros. Each span will have 17 segment, 18 segment, and we will stretch it with the pre-stressing and directed. So that can be, that particular concession can negotiate with the, not sharp curves, maybe radius more than 1,700. So in high-speed train, normally the radius will be more than 6,000. Exceptional case like Vadodara, what the two curves, S curve, going inside and coming out, that is around 175, where the radius is 1,700. So where the radius is coming down, we used to use the segmental concession without reducing the span.
So for what you said about segmental, so normal gantry crane is enough, or we have to specially design that for a curve section?
No, when we are ordering the launching gantry, not for that, what you have seen, that is for full span. For segmental, I think I have not shown any photograph, but you have seen in whatever this Gandhinagar, Ranjit Bilkon was having, Afghans was having that launching girder. That launching girder, when we will be designing, that time we will tell the radius will be approximately 700, 800. So that launching gantry, we will use it for sharp curve, and we can use it for big curve also.
Sir, my question is with the Mohan sir.
Sorry,
Sir,
my name is Ramesh. Actually, I'm a South Indian from Tamil Nadu because in L&T, lot of Ramesh was there. A2 is that initials because we used to call it as one initial only, M. Ramesh. So in company, they told Mohan. Mohan is my father name. Sorry. Call Ramesh.
Sorry, sir. Sir, my question is that launching gantry we have installed for the FSLM, and same kind of transporter system can be utilized for the segmental construction, because most of the metro construction works, segmental transportation is dependent on in the night hours only. That is restricted hours. Because of this, that erection speed is very slow and limited. So is there any possibility in future that this kind of transporter system for the segmental construction with this transporter, 8 to 10 segments can be transported at a time, and that construction speed can be increased?
It is possible. Good question. It is possible. Where there is a thick populated traffic, where it is even the night time the traffic is more. If in animated program, animated video, I have shown one thing in the river bridge. One winch is coming on the river rear feeding. Rear feeding means from the back side of the gantry, the segment lift and go center. So with that rear feeding, we can do it. But what happening in the country is ground feeding. The segment, the trailer comes at the bottom. From there, the segment is getting lifted. So it is, yes, it is possible. But only one thing, that particular structure, because this Japanese has designed, the superstructure can carry the load of superstructure. Because the trailer is, girder transporter's weight is around 200, 250 ton, plus on the top of that 950 metric ton. So this particular structure which is erected as loading further double of the truck. So that means your cost will go up. The same thing will be applicable for your segment. You have to design for extra load, apart from the live load.
We'll take two more questions, one from that gentleman, then sir, we'll come to you.
Hello. Thank you for the presentations. My question is for Ramesh sir. So as the session says, designing for the future, I don't see a very long time when we are away from the maglev technology coming to India. Currently, we are doing the bullet train project. So my question was that how different might be the engineering and its challenges for the maglev transit systems? And where the whole approach of the rails is very different in that case. So are we really ready for that? And what kind of engineering challenges we might face if it comes in a very short time to India?
Okay, see, Meglin, fortunately, I've traveled in Meglin from Shanghai city to airport. So I could able to take out the photograph of how it runs and what type of structure they made it. That structure-wise, cost-wise, it is not much. It's a thin structure. There is a beam. Because it raises up by 6 inches, you will feel that you are going up. Then after that, within 1 minute, the train starts from 0 to 300 kilometers. I have the video also. Okay, so in that particular Meglin, what is challenging is only the technology. The construction cost will not be there because I was there in Dholera. You know, you are from which part of India? Gujarat? Orissa. Okay, so see where there is an industrial place, Dholera, where the Dholera will be in 2000. Now itself the project is coming up, but there is some problem with the soil condition. I was having the article in 2050 that will become a big hub. Maybe some $5 to $6 trillion will be developing. I was thinking that Ahmedabad will be connected with Dholera with Meglin because it needs at least some distance because 8 minutes it took from city to airport, in which 2 minutes, 1 minute 0 to 330 and maybe half minute 330 to 415. Then once again that 1.5 minutes for reducing to 0. So 3 minutes minus 8 minutes, 5 minutes only we were enjoying that train was running at 414 kilometers speed. Okay, so technology will be the challenging. Construction will not be challengeable, but then next, the type of where the city and the industrial hub will be connected. There this Meglin will be very good mode of transport and it is very good technology. Because I was referring only this, because in east part I can't able to, because I was there in east part, Orissa I was there, West Bengal, but I can't able to connect this type of maglev train will be financially feasible for a short distance. Only I'm seeing 90 kilometers between Ahmedabad and Dholera, maybe 20 years after it may come.
My question to both of you. During the day, we have heard a lot of insightful sessions on different aspects of infrastructure projects, mostly led by public sector. Two, I think, the BIAL project and the Mundra port led by private sector. So what actually, considering the entire landscape of infrastructure sector in the country, what 1 or 2 major reforms which you would advocate for transforming the infrastructure landscape in the country in terms of the entire implementation cycle, procurement, design, financing, contract management?
Okay, now for your questions, India already facing this type of changes. For example, I told in 1998 that 1 rupees has been taken out from our fuel. It has been converted into road fund and then was invested on the road construction by the Mr. Vajpayee. So after that, when they found kilometers has to be developed by connecting 4 cities and north-south Jammu to Kanyakumari, then they needed the more funding. So then they changed it from item rate contract, that is BOQ, lowest person will get the contract. From that mode, they changed it to BOT, build, operate, transfer. So L&T has started one wing as a concessionaire or developer. What the first session was taken by Mr. this one, Bangalore Airport. So they are developers. L&T was the constructor, EPC contractor. So by developing, developers will be funding the money through the bank, and then government will be putting a consultant for checking the quality and safety. Then funding will be done by the bank, constructed, and after some time, for 5 years, 10 years, 15 years, depending upon that, you can collect it, and you can hand over the project to government. That is built, operate, transfer. After that, BOOT came, one more. Then after that, turnkey project, that is hybrid. Because I'm telling you, because India is changing this different type of project financing, but issue is the stiff competition. The stiff competition, because if they know very well this project cannot be done by 500 crores, people are quoting 500 crores. The day will come, all the contractor will be quoting the project with that cost plus bare minimum profit. The day will come, that time only what question will be addressed. Because L&T is not going with this, where the technology is coming front, where the new type of the project we enter, because there is no competition. When the competition comes, automatically it goes to finance. There is a problem with India. So it's still that qualification of the contractor, not because of they are the lowest. If that will be taken out, no, he is technically competent. He is financially competent. He will be weightage given for that particular part. L1 will be taken as a secondary. The day will come in India, then all the technology, everything will be constructed by the competent people. Yeah.
I'll just quickly add to it. In principle, I do agree with him. What really needs changing is the procurement systems for projects, and then project management system. But first procurement system, and he's saying that the day L1, that whole L1 mentality will go, that time only you will see competent firms arising. India cannot work with just one L&T. It needs many, many L&Ts. It cannot work with the few large architectural firms we have. We'll need many, and we need them larger. Just now, it's very difficult to operate in the poor procurement systems that we have. Unless these are changed, there's no building up of capacity that he was talking about earlier. And then you will see a flourishing of lots of different companies and competition and a growth of capacities.
In between, one mode of contract came, that is EPC. So he was presenting that mega project, because in that engineering is there, he will design is based on the project requirement stipulated in the contract, and procurement will be given, whatever procurement he can, contractor can select it without sacrificing the quality, specification requirement, and then construction. That particular EPC contract also now it is been not properly handled. That is unfortunate.
Thank you to both our speakers for this insightful and engaging discussions. We would like to present a memento from CEPT and CRDF. So please. With this, we reach Dean of Faculty of Technology for her concluding remarks.
Long day for all of us, for those who are actually sitting from morning, and I'll not take more than 2 minutes or 3 minutes, so don't worry, just bear with that. Indeed, this is a momentous day for us with such brilliant minds and such brilliant projects amazing projects that we have heard, which normally doesn't happen during our routine teaching or during routine practices. We have professionals, we have, young tutors, we have students. Normally it doesn't happen like this jam-packed, wonderful sessions in a single day. So thank you everybody for bearing with us for a whole day and sitting here and, listening patiently. Thanks to all speakers as well. Like every year, this idea of a conference began with two essential questions. What does it take to make major infrastructure projects succeed in India? And how can we strengthen the systems of future? Reflecting on the first question, what does it take to make major infrastructure? Like what Dr. Mahadevia said, it is basically, 5 principles of P that he said, and that was absolutely, relevant to, apply to each and every project. That is purpose, purity of intention, perseverance, positivity, and passion. Here we take back the stories of, we take back with us the stories of technical, financial, political, social challenges, complexities of projects, stories of deep thought processes, coordination and collaborations. And what most of them have not said, and what I could see and what I could see in the presentation is, they've not mentioned about the time they have invested, the energy they have invested, and all the moments of, fun with the friends and family in getting these projects realized. So they have not said that's a silent, that feeling that I could see behind every project getting realized. And I think each and every speaker, each and every person who is connected with all these mega projects, they deserve a huge round of applause from us. Thank you. Moving to the second question that we wanted to answer. How can we strengthen the systems for the future? This cannot happen until we ignite young minds, until what Bimal Bhai said, we change our thought processes, and until we, drive the young force who are going to, drive India's economy, infrastructure development for next 20, 25, 30 years. If we do not make them realize what goes behind making these infrastructure projects, I think that's where institutions like us play a very transformative role in inculcating these values. I may also be a bit harsh, but we need to completely change the engineering education, what we have been imparting since years. And we cannot, no longer we can stick to, curriculum that has been designed in 1970s, 1980s, 1990s to make engineers future ready, for 2045 or 2050. So we have to absolutely, and that's world over this dialogue going on, we need to change this education system. And that's where I'm just slightly grabbing this opportunity to what we're doing at Faculty of Technology, what we're doing at CEPT. Our programs are unique in India, both in their content and their pedagogy. For the past 7 years, we have been doing studio-based teaching and learning pedagogy, which is actually, problem-solving methodology, identifying the problems and finding innovative and creative solutions. That we completely believe in interdisciplinary teaching and learning, and we deal with live problems where professionals will come and share their insights, and with academics, they come up with some of the best solutions to the problems assigned. Thank you, Bimal Bhai, for pushing us to do that. This is the forum when I can thank you. So yes, thanks a lot. We work closely with industry professionals, seek their insights, and greatly value their engagement in our studios, pushing each student to a limit. That's the mental push, that's the physical push, that's the energy, educational push, and they have to reach to a solution. That means at the end of their tenure, each student is we're just trying to create a completely different breed of engineers who are going to be problem solvers, who can connect with the society, who are excellent communicators and who are great thinkers. So that's a complete breed of engineers that we are trying to, make. Probably we can see the results in next 10 or 15 years when they're out in the professional world. And forums like this, they act as a catalyst in expanding their vision, and we hope to continue having many more. In the end, I would like to extend our heartfelt thanks to Gujarat Technological University, Gujarat Institute of Civil Engineers and Architects, Contractors Association for partnering with us. Suren, we already mentioned morning. And special thanks to our sponsors, Turner, PSP, Sanjay Constructions, for your generous support in knowledge sharing initiative. Behind the scenes, we have Shivangi, her super efficient team, campus office, IT, everybody, they're working tirelessly, since about a month or so, or more than 4 or 5 months, I'm sorry. And of course, a person sitting here in front row, Suren Vakil, is absolutely behind the scene, but he is tirelessly working, coordinating with his team, with all the speakers, with planning all the details and everything. So thank you, Suren Bhai, also, of course. So thank you very much. We hope to see you in many more next editions to come. Thank you. Thanks a lot.
Thank you, ma'am, for your thoughtful words. I would request the audience to be seated for one photograph, please. I would request the volunteers to please guide group photograph.